the University of Bombay. He has published 12 books and 55 research papers focusing on university education management, equity, and financing. He is also the founder and the president of the Society for Education of Economic Development, New Delhi. We welcome you, sir.
Thank you so much, Amit. Now, I would like to call Devang Vig from KIIT School for introducing Mr. Ratan Datta sir. So, can you please come?
You, Dimple. Greetings to the gallant gathering. My name is Devang Beg and I come from KIIT World School, Zone H4, Pitampura. So assisting us in this endeavor, we have Dr. Ratan K. Datta as the Joint Advisor for India's Department of Science and Technology and leader of National Center for Medium Range Weather Forecasting. Dr. Ratan K. Datta spearheaded advancements that improved global weather predictions and agricultural advisory services. His expertise was sought internationally with a 1970 UN fellowship for allowing him to study in the USA and Japan, followed by the 1973 collaboration with the USSR. From 1976 to 1978, the UN designated him a data processing expert and meteorological advisor in East Africa. India entrusted Dr. Datta as the chief scientist during the pivotal 1979 monsoon experiment MONEX 79 under the World Meteorological Organization. Subsequently, as the director of the International Monsoon Management Center, he orchestrated pioneering data management innovations. India honored him with the prestigious Golden Medal in 1975. His academic influence extended to the University of Miami, where he taught biennial monsoon courses and Pontifice Vatican Academy, serving as one of the 22 scientists in 1986. Prolific with over 100 research publications, Dr. Datta chaired advisory committees impacting IT, environment, and meteorology policies. Membership in elite organizations like IETE, the Computer Society of India, and the Indian Meteorological Society of India underscored his eminence, culminating in the International Biographical Centre, Cambridge, naming him the International Man of the Year in 1992. We welcome you, sir.
Okay, thank you so much. Now, friends, it's a quite a proud moment for us that we have a young, bright Karthik among us, Karthik Verma. Let us motivate him by big clapping. He is the student at Basawa International School in Dwarka, and he will be sharing his thoughts about the Indian National Quantum Mission when his turn comes. Okay, Dimple.
Now, I would like to call Shaisha from Grand Columbus School to introduce Professor Kapil Murthy.
Good morning, esteemed guests. I am Saisha from Grand Columbus International School. Today, on this auspicious day, we have Mr. Kapil Murthy between us. Mr. Kapil is a certified design thinking evangelist and coach. Mr. Kapil's diverse background and expertise in design thinking, along with his involvement in tech and startup circles, make him a valuable asset in navigating an evolving landscape of work. With the fusion of AI and quantum computing on the horizon, Kapil's skill in creating and critical thinking and innovation will be even more crucial in leveraging these technologies to their fullest potential. As the future of work shifts towards active learning and agile careers, Kapil's adaptability and enthusiasm for exploring new frontiers will undoubtedly positioning him for success in this transformative era. Can we have a big round of applause for him?
Thank you so much. Now, may I request Professor G.D. Sharma for his opening remarks and introducing the session that what we are going to cover in it. After his opening remarks, Professor Ratan Datta will request him to share his vast knowledge about this interesting field. Thank you, sir.
Thank you very much, Dr. Sharma. First of all, let me congratulate Professor Pant. Normally, such days are celebrated by education institutions or by the government. It's first time I'm saying that Professor Pant has taken an initiative to celebrate the day, Quantum Day. Let me also share with you about a year back, we published a photograph of quantum. I'm sure most of you must have seen the quantum computer photograph. Some of you might have seen. It's about 1 year back. And it was just left at that. Other day we were having some meeting with Professor Pant and, on Sunday day. And Professor Pant gave 2 books to Dr. R.C. Sharma. And we were traveling together. And one of the book was by Michio Kaku. I happened to browse through and I picked the book from him. I said, I'll read it and then you read it later on. And then I read about this aspect of quantum computing, what Michio Kaku talks about the quantum supremacy, which is going to be the future. And when I saw this group, I said, they are the future. If quantum is future of the world, AI is the future of the world, and the 3 major revolutions which are going to take place, AI already started, generative AI has started, large language modeling has started. Next is quantum computing. And in next 5 or 10 years, by the time you go to the college, etc., you might have a laptop with the quantum commercialization of quantum computing. That's going to be another 10 years. And by the time we are out of the world, you might find the solar energy has taken over, hydrogen energy has taken over, which will help, quantum computing will help in this area. So these are the future, and these are the future revolutions which are going to take place, and it's not too far. In fact, when the quantum started was also when Feynman did in around very soon. And the big bang came when the 2019 and 2020, then the Silicon Valley started fearing that everything is going to change. So that's the change is likely to take place. Now, celebrating day is very important to reach out to the larger number of audience, people in the country, to know what changes are likely to take place in course of time. And to speak on this day, we have 3 eminent speakers today with us. Dr. Ratan Datta is very well known in this field. He has started from scratch. When probably the computer was not there in the country. I remember the first time when I saw the internet in Korea when the first time one of the scholars from USA showed that I'm getting the food security data on desktop. It was 1978. That time internet was not there and the computer was not here. So when the first time computer came, I think Dr. Ratan Datta was on this. And today we are at a level that each one of you are having laptop, arm top and other things. So we have very eminent speaker, Professor Dr. Ratan Datta. Then we have very young speaker. I was asking somebody that where is the Mr. Karthik? Then Professor Pant said, here he is. So I said, I was expecting like Murdia and other people, some senior person sitting and talking about it. I'm glad that you are here and you are going to speak on this subject. And then we have our friend, Dr. Murdia, who has been always engaged and deeply engaged on the AI, quantum computing and other things. He keep on doing as an engineer and other thing. So there are 3 speakers on this in this theme. and I'll share with you some of my thoughts at the later stage. But now I'll take this opportunity to welcome all the speaker and all of you and young people, the future of India, and request Dr. Datta to make his initial observation. Thank you. Thank you very much.
Thank you very much. I think Professor Pant has been always very kind to me. He has given me this opportunity to expose what happened in sometime in 1989 when we had the first supercomputer of India. I am telling the story of that. When he was handling the computer science department in IGNOU, I used to be having IBM 360, so I used to visit there and was their council member. When I retired, he made me in charge, chairman of the committee of some 12 persons who wanted that IGNOU can take up BCA, MCA course as a journal. So that's type. And then when I was a coordinator of Indraprasth University, he was then CEO of another private company, big company, where he put somebody to do my supercomputing projection so that I produced that, and K.K. Agarwal was the vice chancellor, and then I got special all the type of things. So that's where I thank Professor Pant. Now, let me tell you about the story of the supercomputer. Sometime in 80s, I was invited after I finished my UNDP fellowship, UNDP job in East Africa. I was invited in ECMWF, European Centre for Medium Range Weather Forecasting, which is located at Reading in UK. And they had their first supercomputer there, and they were working on the medium range weather forecasting for whole Europe. So when I went there, I pointed out the mistakes in tropical area of monsoon area. These people were very excited. They invited me to become as a senior scientist, but somehow that letter they sent it to my boss. They didn't send me the copy. So this continued circulating for 1 year or 2 years. And ultimately, I was sent for 6 weeks, not on a job, but as a fellow. Then I planned, because we had SARC, we planned that we can have a medium-range weather forecasting system for SARC countries. So I prepared a document, and then Professor Jashpal had come as a senior consultant with Planning Commission and sent it to him, because he wanted that. Then he became our secretary, DST. Our department changed from tourism, civil aviation to the DST. And Professor Jashpal became the secretary. So process started. Then Bangladesh wanted the center to be opened there. We said, all right, you open it. But we started our own process of building up on this. That's how this supercomputer, which is lying now as a sample in 62 sector of Noida, NCMR Doljav's office, which I purchased 35 acres of land for 800 rupees per yard. And that supercomputer is lying as a model. Now they have a much bigger Cray system. So this was a story, and Rajiv Gandhi was I don't know what was happening, but somehow there we forced him to come on 25th March, which was Sunday. And then we invited all the secretaries of the Government of India to come to IMD campus, and whole process was done. Then suddenly, because we were very close going to the US embassy, chart the affair, dinners and that, I found somebody, I don't want to give the name, DRDO person. He talked, well, I have a senior officer in DST, and I can get anything, but we don't want. Now that made government of USA to send 11-person team from Pentagon to sit on my head for 2 days to see what secret information is being this. Because that was the type of thing which supercomputer used to handle. So that's where I found, what is it? Why do you come all the places? You could have asked me directly. No, sir, this was the... Anyway, that's all. I faced the problem, but that's all. Supercomputer was there. We started weather forecasting. I hope today's weather forecast was good. So I have been talking about quantum computing because I was taught quantum physics by Professor Aulick of Delhi University. He came to Punjab University to give a lecture series for 6 weeks on quantum computing. And then Dr. Kothari was my examiner for my dissertation, which I did alpha-ray studies on scintillation quantum. All type of things are gone. So this, okay. Now, we have been talking about quantum computing, but before that, supercomputing, we went to that very large instruction world. This was very good. Next. So we talked about superscalar and instruction pipeline, all the things we used to talk to the students. Next. This is the vector processor. This is the system which we had of Cray. This is the vector processor. Those things are available. I think you are going to talk about it more. Next. These are the scalar registers, and these are that vector register. That type of thing which are there in the Cray supercomputer. Next. These are the things which are there, vector register, file in Cray, and Fujitsu system. Because I wrote articles on various magazines and journals on Fujitsu system, because after Cray they wanted Fujitsu system to be more popular, but still Cray is the most popular. Next. So this was another interesting thing which I have been always talking, Amdahl's law. 1967, Amdahl said if you have more processors working on a same computer, the things will be worst. The 10 processor will be giving you output less than 1 processor. Whereas Neil Gustafson in 88 came with some 3-page note that it can happen. It can really have the curve like this. That means it should not become 0, it will become like this. So that, because when we went for benchmarking, we had a team of 3 persons. I was from IMD, then became member of DST, and there was a person from DST and there was a person from IIT Delhi. 3 of us went, but I had sent my programs, everything there. So their problem was how we wanted to see where, because Cray computer is named after Samuel Cray, the person who first devised this system. So it was in a village, which is very snow-ridden place. So Ram Gupta, who was B.Tech from IIT Kanpur, had done PhD there, was processing to do Cray YMP. So we said we must go there. They said, no, it is very difficult, but we forced the Cray people to take us to the village, and we found the Cray was being manufactured there. And Ram Gupta came to India as a special honor for giving a lecture. I said, why do you have only 8 processors? Why don't you have multiple thousands of processors? He said, no, I want to be happy with the 8 processors. But when he came in 92, after 88 paper, he had already done 256 processors. That's the type of things which has happened. Today, the Cray system which is having at NCMRWF is having about 2,000 processors working together. So that, and there are, if you see, supercomputer on the top at the moment is IBM, China is the number 2. It is having millions of processors working together. So that type of things has happened. Next. So this is what Mahabharata I said, because few horses, we were talking at the time, we wanted few horses, but now we are talking of few ants, multiple ants, millions of ants, and that's where the present supercomputers are working on that. Next. So this is the type of thing which has happened, that is 210 to 2030. So therefore, all the things comes to ultimately end up at quantum computing. That I have been talking to various universities, IITs and all that, of quantum computing from starting with supercomputing. I have been talking about quantum computing with that. Next. So this is the one quantum computing of, this is the one which goes on. Next. So this is the quantum computer, liquid processor and solid quantum. Solid can be sulfur and phosphor doping. So these are the various things which is happening, because after all it is electrons which are the basic property. Next. Okay, so Moore's law, the study of matter of atomic level, this is again Dr. Feynman, who was the Nobel laureate of 1980, we'll see that diagram. He is the person who really said why you go from higher level to the lower level. That means you go from metric, then come to micrometer and nanometer. Why don't you go from below above? That means from electronic go above. Next. So this is the previous diagram. Now this is the diagram where you have possibility of both superposition as well as entanglement of this. You will study of all this. Entanglement happens, superposition happens. So the same thing can be happening 0, 1, 0, 0, 1. Next. So these are the things which can happen. So prime factorization, cryptography, Peter Shor's algorithm, hard classical computation becomes there. So that is why number of I found only one Indian scientist name who was the earlier student of IIT Delhi, Love Grover, who did a wonderful job of doing N search in N under root time, which was well-known paper, which is referred all the time, but I don't know what happened later. I have not seen him, any research by this gentleman there, but that's the wonderful thing which he did. Next. So this is the basic thing, quantum compiler, quantum this and all that. The next. Okay, this is a particular quantum computer architect जो आप दिखा रहे थे. So this is the architect of a quantum computer. Next. Okay, next. कहाँ diagram कहाँ है? Next. Okay, this is one diagram which I wanted to show. It looks right from 1900, somebody was working on the computing. You know Turing test and all that. You know all the things. But now, first only 3 people got the Nobel Prize who did the computer. Now, no computer guy gets the Nobel Prize. It's because it's known as a technology. Only they get Turing Prize. So that's what you can see. See, Planck's quantum hypothesis, and so on you go right up to this. This is the Feynman, where it comes to be 82. Where is Feynman? 80. Okay, that's 81. Okay, so this, I have seen the movie by Feynman, who was known as a crack scientist, who wanted to build up system from there. And he worked 2 years as a special officer with Microsoft. And that's where he started doing all type of things. They said, all right, he's a Nobel laureate, let him do whatever he wants. But this led to the concept of building up this quantum computing. Next. So this is where, so you could see 1990, 1900, Max Planck, quantum hypothesis, Albert Einstein, photoelectric effect, Neil Bohr and Bohr models, we know, and then we say Warning-Heisenberg, uncertainty principle, next. So then Einstein, Podolsky, Rosen, of the basic questions and completeness of quantum mechanics. Then 1930s, John Newman and mathematical framework for quantum mechanics, they developed the mathematical framework for computers and all that. Richard Feynman's vision of quantum computer came from Richard Feynman and Paul Winford and quantum Turing machine. And let me tell you, Turing was very helpful in World War II. He was a scientist, but was very helpful. But somehow after the World War, he was sentenced to death because he was, आज तो हम कोई problem नहीं है. We can say that he was homosexual. So that's why he was punished to death. But Turing test, Turing award is most important even today. Paul, next. So David Dutch and late 98, research on quantum logic gate started. Peter Shor's algorithm, first quantum algorithm was built up in 1994. 1996 is the Love Grovers, the first that can search a database of n electrons, any n element in roughly n under root steps. Whereas generally log n can be done, but this he did n under root steps very well. Next. So 213 D-wave system and quantum annealing. Then Google in 2019 had built up a super quantum computing with 53 qubits. And 2020, IBM has built up with Q system with again in the next 2022, India-Finland agreement. I think Prime Minister was talking to the lady who was then the Prime Minister that we should work on quantum computing together. And that became an important mission. And I think India has also developed, India and Finland led the IIT Madras, IISc Pune and CDAC Pune. They developed a 5-qubit system. I hope, one can hope that 128 qubit system will come, which will solve all the problems. Because all crypto problems, you'll have to redo everything. Because what cannot be done in a few minutes can be done in 10,000 years. Because there are some problems which any supercomputer of the other type, which the electronic computer can take 10,000 years, this quantum computer can take few seconds or few minutes to do the job. That's what is the future. Future lies with the, as Professor Saab said, future lies with quantum computing. Hopefully, I don't know, because I never imagined that you could come to the quantum computer like your mobile. But maybe it can, but I don't know. But quantum computing, as the moment, is a very, very good. It has been going on since 1994, but still it has not come to the production level. It is research mode, it is being used. Next. So Shor algorithm we have seen, Grover's, this quantum algorithm and cryptographic. So cryptographic, all your rules will change because cryptography will go to defunct because 128 bits will make everything useless. So that type of thing will happen. Next. So at the infancy stage of IC chip of 1958, 50 or so, because that time was the chip, quantum error correction problem is more important because, and then life of the electron or proton at that stage, when excited stage is few nanoseconds, that means you have to do all the calculation within that time. So hot technology, new paradigm, unlike digital, because digital is when we were seeing digital is very susceptible to time, but now we see quantum computers is much more susceptible to time because it requires much smaller time in managing it. Next. So a single electron trapped in the cage of atom, electron remains in excited state in microsecond, duration of each pulse, nanosecond, limiting a number of computation steps. So that's important. Constructing quantum dot is very difficult. How to cram thousands of lasers into tiny space, technology is to be evolved. That's what the research is going on. Other mode, use of individual atoms are the polarization of the laser light as information medium, and that's again another problem. Next. So go to sea of molecules and store information, then use the effect of magnetic field and relate 1 or 0 with the direction of the spin. Nuclear magnetic resonance, Dr. Grenfell is spearheading this technology. Problem of coherence is most important in this. Next. So research center in India, Indian Institute of Science, Bangalore, focus on quantum algorithm, information of error correction. IIT Madras and Harish Chandra Research Institute in Allahabad is doing the work. Private sector, TCS, Infosys, because after I think the government of India started talking of quantum computing about 2 years back with the Finland and everybody. That's the time they started working. But I don't think in 1990s or 2000 or 2020 anybody is working on the quantum computing. We have been giving lectures on quantum computing, but not anybody has been working on quantum computing. TIFR, Tata Institute of Fundamental Research, made a 5-qubit quantum computer, will also promises to have 7-qubit. This TIFR is doing fundamental work. International cooperation, PM Modi talked to PM Finland, Sanna Marin, regarding AI and quantum computing. Next. So, I think because I was given only half an hour, I just tried to cover up this. So that's the basic thing. Because after retirement, I have been working with IGNOU and also working with MERIT. MERIT is Mojal Educational Institution of Research and Technology. I am honorary director there with my wife, their principal. All these faculty members are sitting there. So we have TOEFL GRE tests. We have IGNOU's BCA, MCA, postgraduate diploma, and geoinformatics, all these things we are running. And then we have a ITI, we run on COPA and database courses. And then we have PSI and Microsoft, all these tests are being done. We have a world-class lab there. So we run all type of tests. So things are going well. And that's the MERIT, which is at Qutub Institutional area, which is not far off from where I was working in DST. So it is very close to that. So that's where I'm working. Thank you very much.
Thank you very much for taking us from the time the supercomputer was introduced in India and then moving on to from supercomputer to quantum computing. In fact, that's the kind of story he has taken us from there. And he also mentioned about two of very important persons in Indian science. Particularly, he talked about Yaspal, who is, I think, a very key person in introducing many things in an innovative manner in ISRO and subsequently on the communication system also. And he also talked about the Kothari, who was the first person to think about physics and education and development. But from taking the supercomputer, he moved on to the quantum computing. And the one big name he took was who got the Nobel Prize, Feynman, Richard Feynman. His was a very big change which has brought to the system of computing in the world. You heard about 0 and 1? Have you heard about 0 and 1? Yeah, ये पुरानी कहानी है. And then 0, 0 and 1, which he sort of talked about digitization. And Feynman, there could be something more. And so something that within some quantum you can put it more information, and there could be simultaneously 0, 1, and then moving in a manner which is often shown. And that's a big change it has brought. And that's what Professor Dr. Ratan Datta brought out, how changes started coming after that, slowly down to 1959 to till date. And today we have four major quantum computers in the world. Sycamore is one of them, but we'll talk little later on some of these aspects. But I must congratulate Dr. Ratan Datta. He lived with this. That's very important part of it. That how things go. Talking and doing, explaining is one thing, but doing is another important thing. Developing supercomputer was a major breakthrough in Indian history of science and computing. And then now knowing how quantum computing is going to change the world, that's the kind of beginning. Thank you very much for enlightening audience on this aspect. And now, once again, thank you.
Okay, thank you, sir.
Yeah. आप कुछ कहना चाह रहे? अब इनका नाम आ गया ना?
Yeah, I will.
अच्छा, now I would like to invite the young scholar, Dr. Mr. Verma, the Karthik Verma.
Speak. He is a student, bright student at Basawa International School, Dwarka. So most welcome, Karthik. And in the meantime, when Karthik gets ready, let us welcome Professor Mukhopadhyay. He has just joined us. So thank you, sir, for coming.
All right. When you change the way you look at things, the things you look at change. Good morning to one and all present here. I am Karthik Verma, a 12th grade student currently studying at Basawa International School, is privileged to speak and put forward my views and thoughts about the Indian National Quantum Mission on the occasion of World Quantum Day. Firstly, the question arises, what is quantum? Well, quantum arises from Latin, meaning an amount. It is the small discrete unit of a phenomena. The Indian National Quantum Mission is a visionary initiative aimed at propelling India to be at the forefront in quantum science and technology. The Union Cabinet approved the mission on 19th of April 2023, which was chaired by our Honorable Prime Minister Shri Narendra Modi. With this initiative, India will be the 6th country to have a dedicated quantum mission after US, Austria, Finland, France, and China. The mission offers revolutionary capabilities that promise to redefine computing, communication, cryptography, and sensing, led by the interdisciplinary team of scientists, engineers, and policymakers. The mission seeks to accelerate the development and deployment of quantum technologies across various sectors, including healthcare, finance, defense, and beyond. The mission aims to position the nation as a global leader in quantum science and technology. NQM is expected to set up 4 mission hubs in quantum computing, quantum communication, quantum sensing and meteorology, and quantum materials and devices, which will essentially be consortia of academia, R&D labs, and industry. Well, it's truly said, the things we do have certain objectives that are to be fulfilled. Certainly, this mission also has. Number 1, quantum research and development. The mission aims to foster a vibrant ecosystem for quantum research, innovation, and skill development. Quantum communication and cryptography. INQM emphasizes the development of secure quantum communication networks. The quantum-resistant cryptography essential for safeguarding sensitive information in the digital age. Third, quantum computing. The mission seeks to advance India's capabilities in quantum computing with a focus on developing indigenous computer, hardware, software, and algorithm. Quantum sensing and meteorology. INQM endeavors to leverage quantum sensing and meteorology for applications in precise measurements, imaging, and navigation, with potential implication in healthcare, defense, and environmental monitoring. Number 5, Human resource development. INQM places significant emphasis on training and nurturing a skilled workforce in quantum science and technology. The INQM stands as a testament to India's ambitions to leverage quantum science and technology for the betterment of society and the advancement of knowledge, positioning the nation as a key player in the quantum revolution. The technologies that rely on quantum phenomena are all around us. The first wave of quantum technologies gave us the transistors. We also have another examples. For example, MRI scanners for medical imaging, lasers, solar cells, electron microscopes, atomic clocks used for GPS, and many more examples such like these are there. As we embark on the historic journey with the Indian National Quantum Mission, let us remember that the pursuit of knowledge is a collective endeavor. Let us collaborate, inspire, and pave the way for a quantum powered future. With this beautiful note, I would like to conclude myself. Thank you and have a nice day ahead.
Thank you very much for narrating the kind of changes which are likely to take place. And let me share with you a secret. He is not a physics student. He is a student of commerce. That's big change. That today it is not limited to those who are learning the physics or who are doing the physics. But anyone who is interested can do things which are of, and that the system enables them to do it. That's very important aspect. He also talked about the crypto and आप कुछ कहना चाह रहे हैं?
Yes. Neither Bill Gates nor Steve Jobs, none of them had gone to the college and they didn't know anything of computer. They have become the brilliant computer person.
Yes, that's what the say. That's what I said. That's what the secret. I said that this is the secret of that those who are not they because they can think afresh and that's they contribute to the kind of a thing. So we had a very good presentation by him, and he talked about crypto, and crypto's enemy is quantum. That's the way it happens. That cryptocurrency, blockchain, etc. are not breakable, but they are breakable with the quantum. But one thing you must remember that at the back of it, there is a lot of energy required. Supercomputer, I think he might tell that kind of energy a supercomputer requires is very high. And if you have energy problem, then you won't be able to. So we'll discuss about all this, but we have very important person who is working on the AI and quantum, Mr. Kapil. Kapil is coming. Kapil is already here. So Kapil Murdia, he has been regularly speaking on the subject of AI and also trying to work on, he's basically an engineer and working seriously on the subject, and then he also wants to share his ideas on quantum computing. And before he comes, then you know the world is having about how many computers, quantum computers we are having in the world now? Can anyone tell me? No, other than Professor Panta, Dr. Datta. How many quantum computers we have in the world now? Okay, I'll share with you. The Sycamore, I already talked to about Sycamore, and then Osprey is there of IBM with IBM, and then there is another Chinese, Zhuang, of China with 76 qubit and bit and qubit, you know about it now. And then there is a Google with 72 qubit, which is called Bristol. And then you have Sycamore already, which is 53 qubit, and the Tangle Lake has about 49 qubit. So highest
India
among
also has 5 qubit. Indian Institute of Science also has 5 qubit.
5 qubit. We have started. So we are in the race. We are in the race. I'm glad that you may not find this kind of information which you shared with me in the literature and books, but India is also not far off because we are entered with the 5 qubit. It's a very big thing. And if we can go with 5 qubit, we can go about the higher qubit also. So now we have the Mr. Murdia.
Yep.
So 5 qubit के बारे में फिर बताएंगे आप थोड़ा सा?
5 qubit. Indian Institute of Science, Bangalore. It's a 5 qubit Indian Institute of Science, Bangalore. After Prime Minister Modi talked to the Finland people, they started working on it. So 5 qubit, जैसे bits है कि 0101, इस तरह 5 qubit क्या करते हैं. But ultimately, one wants to go to 128 qubits, then whole problem will be solved.
Which is almost, it requires a lot of, they have ISS 76 qubit right now in the world, that's why kind of. Well, Mr. Murdia.
Okay, so, all right, so a lot of interesting young faces. So what we will do is, I'll play a video to get you all excited about quantum and AI, and then we'll do a quick short presentation, and then we'll open it up for the discussion. Does it work for everyone? Yep, thumbs up. Okay, so let me just play the video for you guys. Sound?
Imagine the Ever wonder how the workplace will look in the future with the rapid advancement of AI and quantum computing? Imagine the office of tomorrow, humming with artificial intelligence, machines and humans working side by side. It's a transformation that's already begun, and it's stirring up a whirlwind of emotions. But AI is just one piece of the puzzle. Enter quantum computing, the ultimate frontier of computational power. There are those among us who view this shift with apprehension, fearing job loss and obsolescence. Yet, there are others who are excited by the potential of AI and quantum to augment our abilities and transform our economies. Such divergent views raise the question, are we headed towards a dystopian world where humans are rendered redundant? Or are we on the verge of a technologically advanced utopia where AI serves to enhance human productivity and creativity? This video is a journey into the heart of this debate. So, are we headed towards a jobless future or a technologically advanced utopia? Let's dive into the world of AI, quantum, and work. Consider the global retail giant Amazon, for instance. This titan of industry has harnessed the power of artificial intelligence in ways that would have seemed like science fiction just a few short years ago. Take inventory management. Amazon uses AI to predict what products will be in demand, when, and where. This way, the right items are always in the right place at the right time. The result? A much more efficient system. AI doesn't stop at inventory, though. It's also a game changer in customer service. Amazon's AI-powered chatbots can handle a vast amount of customer queries, freeing up human agents to tackle more complex issues that require a personal touch. This combination of AI and human expertise offers customers a more seamless and efficient service. But perhaps the most visible use of AI at Amazon is in delivery. The company is pioneering the use of drones and robots to get packages to customers faster and more efficiently than ever before. These AI-driven machines can navigate complex routes, avoid obstacles, and even, in the case of drones, take to the skies to bypass traffic. Of course, these advancements haven't come without their challenges. The rise of AI has meant significant changes for Amazon's workforce. Jobs that were once done by humans are now automated, and new roles have been created that require a whole new set of skills. So what's the takeaway here? Well, it's clear that AI has the potential to greatly increase efficiency and improve customer experience, but it also means big changes for the workforce. The key is to embrace these changes, to adapt and grow with them. Clearly, Amazon is a prime example of how AI can revolutionize the workplace. Perhaps the most profound impact of quantum computing on the future of work lies in its potential to unleash a wave of innovation and discovery. By harnessing the power of quantum algorithms, researchers will be able to tackle some of the most intractable problems facing humanity, from climate change and disease to poverty and inequality. The possibilities are truly limitless, with quantum computing serving as a catalyst for a new wave of scientific breakthroughs and technological advancements. Imagine a world where diseases could be diagnosed accurately, swiftly, and without human error. That's what IBM Watson brings to the table. By analyzing vast amounts of medical data, Watson can identify patterns and anomalies that might escape even the most experienced doctors. This isn't about replacing our trusted medical professionals, but rather giving them a powerful tool to aid in their diagnoses. Let's delve a bit deeper. Watson isn't just scanning medical records, it's learning from them. It uses machine learning to understand the nuances of different diseases, allowing it to provide more accurate diagnoses over time. Now that's a smart machine. But Watson's capabilities don't stop at diagnosis. It's also revolutionizing the way treatment plans are devised. By considering a patient's unique medical history along with the latest medical research, Watson can suggest personalized treatment plans that are most likely to succeed. It's like having a supercomputer for a personal health advisor. Now, managing patient data is a colossal task. It's not just about storing information, but organizing and understanding it. Here, Watson shines again. It can process millions of patient records, research papers, and clinical trials in a fraction of the time it would take a human. This allows doctors to have a comprehensive understanding of a patient's health, making treatment more effective and efficient. But remember, Watson is not here to replace our doctors and nurses. Instead, it's here to augment their skills, to provide them with the kind of data analysis that would be impossible for a human to achieve. It's a partnership, a co-pilot to guide us through the vast and complex world of healthcare. With Watson, IBM demonstrates how AI can transform industries by working in tandem with human professionals. Watson's role in healthcare is a testament to the power of AI, not as a replacement for human expertise, but as a tool to enhance it. From retail to healthcare, AI is undeniably reshaping the work landscape. As we've seen in the case studies, companies like Amazon and IBM are leveraging AI to streamline operations, enhance customer experience, and even revolutionize healthcare. Emerging trends are becoming more apparent as AI continues to integrate into our workplaces. One such trend is upskilling. As AI takes on more repetitive tasks, the demand for more complex human skills is increasing. Companies are investing in training programs to equip their employees with these in-demand skills, ensuring they remain relevant in the evolving job market. AI ethics is another focal point. As AI systems become more autonomous, the question of ethical decision-making becomes paramount. Companies are now prioritizing transparency, accountability, and fairness in their AI applications, striving to avoid bias and protect user data. Finally, AI is causing a shift in job roles. While some fear that AI could lead to job losses, it's essential to remember that it also creates new roles. Data scientists, machine learning engineers, and AI ethicists are just a few examples of the new professions spawned by this technological revolution. The future of work in the age of AI is here, and it's a blend of challenges and opportunities.
Quick comment before I just quickly switch on to my presentation. Thank you. Okay. So quantum disruption and future of work. So we've been talking about AI, we've been talking about quantum, but how would all of this impact the modern workplace? How would a workplace of 2030 or 2040 look like? And what does that mean in terms of all of the young people who are out there, who are in their schools or colleges? How should they be prepared for the change? So what I'll do is I will throw up some ideas in terms of what we believe or what we have heard, seen, read around the future of work and how that is getting disrupted because of quantum and AI. And then we'll probably open it up to a discussion. So let me just quickly start. So I'll start with this tagline and this thought for all of you to remember. So strange coincidence or a self-fulfilling prophecy. And I'll just explain what I mean here. Does anyone know this person apart from Ramesh sir? Young people know everything. Very nice, very interesting. So this gentleman is a guy called Salvador Dali. He was the pioneer, or he was one of the greatest proponents of an art form called surrealism. So surrealism, and that was World War One or two times, and the world has just came out of the war, and there were various forms of expressions people were exploring, and one of those forms was surrealism, and he was a proponent of that. So, and it was, of course, as it goes, as any of you people who are from the art community, arts and humanities community, there are these avant-garde sort of artists who always challenge and defy the mainstream. So he was among that group of people. And interestingly, the DALI E, if you have heard of that large language model, is actually named after him. So, and why I actually brought this topic up. So this surrealism movement is very interesting and has some very interesting coincidences with what's happening in the world today. So this was actually a reaction against what people saw, the distraction brought by something called rationalism. So they thought that people were getting too rationalistic, and that actually led to World War I and II. As I told you, surrealism actually was a byproduct of that era. So what they started saying is that, in our art forms, in our paintings, we'll start reuniting the conscious and the subconscious mind. And a lot of them were heavily influenced by Sigmund Freud. So they said, let's sort of, blend the conscious and the subconscious mind. And then what they did was they came up with these art forms where, the world was very minutely depicted. There were a lot of interesting details. And if you see this painting here, this is one of the paintings by Dali. So very minute details, but nothing rational about it. So where would you see a flat and a damaged kind of a clock in a rational world? So what they did was they were always, and remember this phrase, switching the context. So you have a clock, but they switched the context. They gave it another form or a shape. So, and then what they did was they kind of connected the dots. They reassembled things in a very paradoxical, bizarre, and in a shocking sort of a framework. And as I said, they were all heavily drawn and influenced by Sigmund Freud. Now, imagine for a minute what's happening in today. So if you think about quantum and AI, think about this. Our civilization is maybe 2,000, 5,000-year-old civilization, and at multiple times we did that quantum switch, that context switching. With quantum and AI, that quantum switching, that context switching is happening in a millionth of a second. So that context switching that has happened over the period of civilization is now happening in a millionth of a second. So how bizarre, how irrational that world could be. And so what I'm essentially trying to say is that if you actually look back and reflect on those times and those art forms and what they represented, and think about replacing those unconscious that Salvador Dali was talking about by quantum and AI. And at the end of the day, quantum and AI are those expressions of subconscious, if you look at it philosophically. What this means is that you exponentially switch context, and this exponential switching of context, and a lot of people are saying could actually lead to irrationality and threaten even our very existence. So, not to scare you a lot, and just this quick, if I can just explain this with an example. So this is a famous paper on which all large language models are based. It's called Attention is the Key or something. And so in this they have this attention equation. So they have queries, keys, and values. And this attention equation actually represents how the machine would look at self-attention. So if you look at this example, he went to the bank and learned of his empty account. So machine understands that bank and account are the same context. And then he said, then there is another, in the same sentence, you have got river bank, and then he cried. So the machine understands that river bank is different and the bank, as in the financial bank, is different. So this identifying the context is called self-attention. And the way this works is it's actually all reduced. If I look at this as a reductionist problem, this is all getting reduced to a simple mathematical equation. Attention QKV is, and this is that equation. And in this, it's queries, values, and keys. Now, what happens if tomorrow machine learning and machines are able to define and work on their own keys? Where will be the checks and balances? So imagine if machines someday decided that the bank, as in the financial bank, and cried were related and not the river bank and cried. Imagine the havoc these autonomous machines could play in future. So which actually brings us to the next topic of rationality. So Pansar has been talking about this, and this is a very interesting topic, and there's a very interesting book that was published a couple of years back by Steven Pinker. So in this book, he talks about rationality is actually very important for improving our world, and people actually misunderstand rationality, and then he actually tries to explain what is rational thinking. So he says that rationality is all about using knowledge to attain some goals. And within this definition, he says that knowledge is actually a belief that can be proved empirically or with experience, with judgment, and so on and so forth. And then he says that, we think in ways, if we think about our thinking process, so we think in ways which are sensible in low technology context, where context switching is not happening that frequently. But then we fail to take advantage of the powerful tools that we have today. And we have so much data, we have so much tools for analysis, and we actually fail to use those tools. And then, he also says that the pursuit of, and he actually gets a little bit more critical there, that when he says that, pursuit of self-interest, sectarian solidarity, uplifting methodology by individuals can actually add to the crippling irrationality in society. So, where are those forms, where are those sources of irrationality coming from? And then he actually, lays down that criteria, that collective rationality. He gives a word, collective rationality, all of us being rational as a society and not rational as an individual. So collective rationality depends on norms that are explicitly designed to promote objectivity and truth. So we've all heard of deep fakes. So if you actually think about this, what we today need is that collective rationality. I want to move on very quickly and just leave you with this thought, and then we'll actually flip this topic. So education is not the learning of fact, but training the mind to think. So future of work. So this was one thread of conversation. I'll bring in another thread of conversation now, how all of this impacts the way of, the future of work and how the work would look like in coming decades and so on and so forth. So very famous book. Again, Pansar has talked about this a lot, The Rise of Useless Class. So what happens is Harari in his pioneering book talks about that at the end of the day, organisms are algorithms. So every animal, including Homo sapiens or human beings, are an assemblage of organic algorithms that have been shaped by natural selection. And then he makes a very interesting point. How does it matter how your brain is composed, or or how the instrument or something that processes all of this intelligence is? It could be your brain, and it could be a plastic, it could be a silicon. So the materials do not impact these algorithmic calculations. At the end of the day, you just care for the end, and these materials, whether it's your brain or your computer, are just means to that end. And so there's no reason to think, and that's where he comes up with something very serious and interesting, that there's no reason to think that organic algorithms cannot do. So when he says organic algorithm, it means our human brain cannot do things that algorithms will never be able to replicate. So our brain is sacrosanct or infallible vis-a-vis the machines is a premise that he's challenging. So with that, he then actually makes a very interesting point about the future of work. He says that it's actually easier to replace human beings with algorithms, not because algorithms are getting smarter, but because human beings are themselves professionalizing. So we are moving into this area of niche, and then he says that a cardiologist actually who specializes in a very narrow niche is someone who is very easy to replace than a hunter-gatherer. So think about a human being 5,000 years back, hunter-gatherer. So if you think about his job profile, he has to prepare the spear points with flintstones. He has to find edible mushrooms. He has to sort of track down a mammoth or a bear. He has to coordinate with his other other fellow hunters and try and track down and hunt the animal, and then use the medical herbs to bandage all his wounds. Think about the range of skills, the repertoire of skills that person is dealing with, and compare that with a modern day cardiologist, and then you'll realize that a cardiologist is far more easier to replace than someone who has a broad range of skills. So a lesson for us, all of us, expand and broaden your horizons as much as you can. The world of tomorrow will be an interplay of both generalists and people who specialize. But all you have to do is you have to understand, you have to have that ability to connect all the dots together. So I'll actually just quickly move on and make this important statement. The crucial problem is not about creating new jobs. The crucial problem is creating new jobs where human beings will be able to supersede or perform better than the algorithms. So this is future of work. I think we'll probably skip this. So I'll just pick up a few trends and then probably open it up to discussion. So if you think about today, what's happening in the world today, so they are, people, if you think about organizations like Google, Delta Airlines, they are now getting away from degrees, so we don't need a graduate or a postgraduate, and I'm not here on a public platform commenting that you should not do degrees, but what I'm saying is that, degrees it's just a means to an end. At the end of the day, it's also about constantly upskilling and relearning and unlearning all the time. And the days when you had your degree and you were done for your life are far gone. And then if you think about the other leading organizations and how they are hiring, and I come from with an HR background, a lot of these companies are now looking at in-house universities and really that apprenticeship model, of education, which is about real practical skills, real practical skills, and not just knowledge and so on and so forth. So the traditional stereotypes of career paths will collapse. There will be more and more lateral careers than vertical careers, and so on and so forth. So if knowledge is power, knowing what we don't know is wisdom. So this is a famous author, Adam Grant, and he makes this comment. So let me just actually bring up a few things and then we'll close it up. So what should I know? And this is interesting for all of us who want to think about the jobs of tomorrow. So there is tacit knowledge and explicit knowledge. Explicit knowledge is all your manuals, your documentation, your books. It's printed, ready there. And the danger is that explicit knowledge can be very easily retrieved by a crawler, by a chatbot, by a chat GPT. What is of immense value is something called the tacit knowledge, and that's what we should all be thinking about. So tacit knowledge is all about expertise, it's all about insights, your intuition. How do you sort of deal with the situation intuitively? How do you process that situation? How do you process all that data? And even your values, your traits, and how do you sort of, how do you sort of use all the mental models? So where can you use tacit knowledge? In innovation, ideas, emotional intelligence, language, and communication. I'll probably go a little fast. So I want to actually challenge you. So knowledge, we have ChatGPT on our fingertips. We know what to do with ChatGPT. So what do I do with all this knowledge? How do you sort of use this knowledge? How do you sort of use your knowledge to actually grow yourself and grow your careers? So I'll give you a few ideas. So if you go back to that discussion with Salvador Dali, so there was conscious and there was subconscious. So if you think about any mental model that you often would use, it could be any mental model. It could be a Pareto principle. It could be how you manage time. Any mental model. So there will be a deliberate a conscious use of a mental model, which is data driven. You see all the data, you probably visualize it. If you are a visual person, then you put in all the scenarios. But there will also be a subconscious application of that mental model, and which is where you will generate those ideas. So this interplay of deliberate and subconscious or autonomous is something that you should target. And then if I can actually leave you with this thought, the 5 cognitive dimension of mental models. So, you've got instinct, faith, preference, logic, and evidence. Now, as you go high and high up, you can see that, you're deliberately trying to apply your mental models. You're working with data. You're trying to think about, you're trying to rationalize. You're bringing in that rational thinking. And the more you do that, the more you will be safeguarding yourself with things like deep fakes. And And I think the important thing here is instinct and faith. And instinct and faith faith and instinct are, as with any other thing in this world, they are both double-edged sword. Faith at certain level is good, but excessive faith, I am everything. And Socrates and the greats in previous history have always challenged that. So excessive faith on an individual is something that might be extremely dangerous. So I'll probably skip this in the interest of time, but I think the slides are available, and I've given some examples and some ideas as to how do you sort of use these models. And yeah, I want to actually just close this with a final thought. So a lot of people out here are from the education and teaching community. So what does this mean for all of us? So the famous saying from Buddha, be the lamp unto yourself. So the teacher of tomorrow, how would the teacher of tomorrow look like? And I'll give you a couple of case studies real quick. So this is a school of tomorrow, and I think Pansar had spoken about this. This is a school called School 42. This started in Paris. And the interesting thing about this school is no teachers, no classes. So some of you young students would really be intrigued about this. And they have a project method. And then they're saying that, if you fail, if you try out a few things, but if you fail, that failure is part of your learning and development. That failure is actually a progression and not a setback. And the most important thing here is peer-to-peer learning. So they put people in peers and batches, and then they learn together. So there's no teacher, or there's no oversight, or there's no one on the pulpit sort of guiding you, but it's all peer-to-peer learning, and even the evaluation is a peer-to-peer evaluation. And then they often say that group work, and when we're working together and we are trying to complement each other, that's not cheating, that's working together. And then the other thing, Khan Bingo, Khan Academy, so they've actually built this teaching assistant, and they themselves say that, we got inspired from Socrates, and and unlike the traditional AI, which is analytical, introvert, direct, and eager to please, Khan Bingo, they claim themselves, is whimsical, eccentric, and brimming with a sense of wonder. So they were heavily inspired by Socrates. I do wonder if they've understood and thought what happened to Socrates, who was whimsical and eccentric, but that's another story. Okay, and this is something that Pansar has always said. So when the student is ready, the teacher will appear. But when the student is truly ready, the teacher will disappear. Okay, I'll close this here. I want to just open it up to discussion and ideas, and if anyone has a critique, and I'm sure Pansar would also have some inputs on this. But thank you so much for your attention.
Thank you. Thank you, Mr. Mordia. You took from the kind of disruptive technology to constructive way of education, using it in education. That's a kind of a journey has taken from the disruption. I would like to ask some of you the name of person who created AI. Can anyone tell me? Have you heard the name of Turing? Turing machine? Turing machine. The Turing first time started thinking, can machine think? And what you are seeing today, everything which you are seeing in the laptop counter, it's the Turing concept of can machine think? And that's the AI. There is a very interesting book on AI, if you want to interest, that is AI 2041, which talks about how changes are going to take place and other thing. And if you are interested in knowing how the quantum and AI are going to come together, I would suggest you better read Michio Kaku. He explained in every aspect.
All the term AI came up. Dorothy and all these, they were having a project like chess playing, TikTok, talk, and all that. Now, when they go to the project, they have to go to NSF. Now, they have to name it. So, name was given as AI. From that, it became famous.
No, the name might be, the person responsible for this was a Turing. Turing thought, that can the machine think about it? And that thinking process came. And today thinking level is such. Some of you might be knowing generative AI. No. Other day I put some data to generative AI. I say, edit it. It edited it. Then I gave second paragraph, edit it. And he says, author is talking like this, author is doing this. He is not editing now, he is telling what you are, how you are. And I say, I have never asked this question to them, but AI has the thinking mind. And that thinking mind is that it is sometimes becomes very dangerous. That's why the people are challenging this. So point is, I'm glad that Mr. Mordia has taken you around how AI is being used, AI and quantum are being put together in terms of using in education processes, etc. Now I'll open it for the some questions if you have in your mind from any of the person who has spoken here, and then we'll close because we are already exceeded the time. It was to close at 11, but we are already 11:31. Well, I'll ask for 2 or 3 questions on this, and then we'll close the session. Yes, please, go ahead. Somebody has raised the hand.
Thank you, Anupam. Yeah, yeah. Yeah, sure. Sure. So I would start with saying that, what cannot be replaced with by machine, and if I actually just go back to that slide that I was saying, how do we actually prepare people for jobs where people are smarter than machines? So what is it machines cannot do today? So if you think about it, can machines imagine? Maybe today not, but they probably would be able to imagine. But what is it machines of tomorrow, or realistically speaking, what is it machines of tomorrow would not be able to do? So one of the things machines of tomorrow would not be able to do that easily would be the ability to connect the dots. So if you look at my presentation, and you actually said this, when you made that comment, I was bringing all the different multiple threads of conversations, yeah. And then I left it to all of you to unpack those threads of conversations. Now machines, at least today's machines, are still designed to, so they work on linear equations powered exponentially, but they're still designed to think in that sequential manner. So they cannot go toggle back and forth. Theoretically, they cannot toggle back and forth. So how would they connect the dots? So I would say that that's the place from where we should start. So knowledge would get obliterated as a differentiating factor will get obliterated. What would actually be important are things like being able to connect the dots, things like being able to use the mental models, things like critical thinking, things like how do we actually be creative, how do we sort of toggle back and forth between our conscious and subconscious. So your conscious is when you're using the data, when you're using the process, and then subconscious is when you're imagining and you're letting your imagination go wild, and so on and so forth. And that's why I actually brought that example of Salvador Dali. So I think that's where I think we should start from. But to be honest, if I were totally honest with you, I am as clueless as anyone else, because I am the product of the same education system. So even I cannot think beyond the obvious. But prima facie, from what we are seeing, this is what we can actually do in our schools.
Thank you so much. Now what we'll do that, it's already 11:34, which we extended. So what I would suggest that this dialogue would continue over the tea, and we may break for the tea, and I take this opportunity to thank Dr. Ratan Datta, Mr. Verma, and Kapil Mordia for making an excellent presentation. And we break for the tea. And during the tea, they are going to be with us. You continue with your dialogue with them. Thank you so much. Thank you.
Thank you, sir. Uh, the tea is outside, just from the left. Go there. And we request that the next session will start at 12 o'clock. So thank you so much.
You can reach out to Asi sir or email me. I'm here. Where do you teach? I work in a company. I'm in corporate.
Sir, I'm a psychology student. Currently, I've just done one of my research on males mental health. And I got a topic that how AI is replacing jobs and how is it possible that
So to correct you, AI will not replace jobs. People who know and understand AI will.
my question is that we've got a question that is this possible that somehow AI will be able to replace psychologists, psychiatrists, neuropsychologists, environmental psychologists, and people have extremely different opinions on this.
Logic, reasoning, subconscious, connecting the dots that cannot be replaced. As long as you are
I'll give
smart
you an
enough,
example. So, you know what happens? That students.
read Kapil. Sorry, read Kapil Singh at Yahoo. मैं भी लूँगा सर आपके साथ सेल्फी मैं अपना सेल्फी ले
हाँ जीमेल पे है किसी
मैं आप ही को मेल कर रही हूँ किसका लॉकडाउन है
किसी का
Yeah. So I'll give you an example. That
I don't very selective. Let's have a chat. आप पूरे दिन where do you work or what are you?
I have a company called Mind. We work for the professional development. We are connected schools across the country. Okay. We do a couple of more work, but everything is around school education.
Sure, we can have a chat. You can have your
Back. We are beginning with the first session, the second quantum revolution. This session will be chaired by Professor Suresh Chandra. Let us learn something about him. Can we have the AV, please? Audio.
EDU TV with 1 million eyeballs across the globe.
Connecting schools, universities, industries, and corporate houses.
Greetings, I'm Adhiri Tripathi, a student of grade 12 studying in Delhi Public School, Bangalore East, India. I'm a passionate student who has served as a part of the Student Council in my school for the past 3 years, and I believe this session on the quantum world will be an enlightening one for all our curious listeners. Therefore, on the occasion of World Quantum Day, I will be introducing our guest speaker, Professor Suresh Chandra. Professor Suresh Chandra is a distinguished figure in the realms of academia, technology, and social welfare, with a bachelor's in electrical engineering in BIT Ranchi, and a master's in controls from Roorkee, and a PhD in computers from IIT Delhi. Professor Chandra's academic legacy lays as a foundation for an illustrious career. He worked as a professor and head of departments of electrical, electronics, and computer engineering at G.V. Pant University of Agriculture and Technology, Pantnagar, Uttarakhand, for about 25 years. He was also a visiting professor in Algeria for 3 years and Mosul, Iraq for 1 year. He served as a member in the Committee for Regulations and Rationalization of Private PL colleges and played a part in the formation of education policy of the state of Jammu and Kashmir. His career extends to great lengths, but I shall try and summarize it in a few lines. He worked on various reports throughout his career, namely the 2000 report on computer education at NSIT, recommending improvements to undergraduate and graduate programs in computer design and technology India. The integrated system of Centers of Electronics Design and Technology India involved in establishing 6 centers nationwide under the Government of India in 1998. The Regional Prospective Plan for Rural Electrification in Hill Areas of Uttar Pradesh up to 1984, which outlines strategies for rural electrification submitted to the Government of India. Professor Chandra's visionary thinking extends to the cosmos, as evident by his 1982 proposition to explore galaxies intelligently through advanced communication systems. His insights transcend the boundaries of conventional thought, hinting at possibilities yet to be realized. Currently, as the Vice President of an NGO dedicated to educating disadvantaged students and children in Gurgaon, Professor Chandra continues to inspire with his multifaceted dedication to knowledge and social welfare. Professor Suresh Chandra, I extend a warm, warm welcome to you.
निकाल के रख लो. So next we have Professor P.V. Suresh, the very young professor, and he is an expert of artificial intelligence very recently. So let us learn something about him.
EDU TV with 1 million eyeballs across the globe.
Connecting schools, universities, industries, and corporate houses.
The study of visible nature is science. But what about the study of nature that is so fundamental, yet seemingly invisible, which consequently our human minds cannot comprehend? That, my friends, is the study of quantum. Ladies and gentlemen, esteemed guests and fellow quantum enthusiasts, my name is Vinayak Singh, a proud representative of Ramdas International School. It is my great pleasure to introduce you to our distinguished speaker for World Quantum Day, that is Professor P. Venkata Suresh, Director of School of Computer and Information Sciences at Indira Gandhi National Open University, IGNOU, Delhi. Professor Suresh is a visionary leader in the field of computer and information sciences with approximately 3 decades of diverse experience, including more than 2 decades in operational, distance learning, and technology enabled learning. His contributions to the field have been significant, particularly in the areas of online education and e-learning technologies. Moreover, Professor P.V. Suresh's 2 decades of experience in technology-enabled learning were amplified by his determination to improve experiential learning for students worldwide, with him leading the way in implementing SMS alert services at IGNU, along with webcasting services through a collaboration with NICSI. This enabled the institution to expand to millions of people across India and the world. The impact of his efforts are not only felt in the hearts of his colleagues and the vast number of students he has worked with, but it has also been recognized by the Scopus Index journals and the STEM Research Society of the Himachal Pradesh University, where he was awarded the title of Best Academician and Best Leadership. His work truly embodies leadership, as demonstrated by his role as principal investigator for IGNOU's Commonwealth of Learning Canada project and his multifaceted presence as the program coordinator of Certificate in Mobile Application Development
वैसे मैं अपना
CMAD,
खुद भी बोल
where
देता
his influence reached institutions in
हूँ
Pakistan,
ये वाला
Sri
रन करना था
Lanka,
मेरा
Malaysia, Nigeria, and Mauritius.
हाँ इनका
Considering the rapid race of the world, he has stayed updated by undergoing training in e-learning technologies at the University of Columbus School of Computing, for which he received a scholarship from the Japan International Cooperation Agency. Currently, he is guiding research in the areas of machine learning and data mining and is actively involved in various statutory bodies of IGNU. His past collaborations with regulatory authorities, universities, and other educational institutions further attest to his commitment to the field and his dedication to advancing knowledge and innovation. We are honored to have him as a speaker today, and we are confident that his expertise in this field will provide us with valuable insights in the realm of quantum computing.
So thank you, Professor Suresh. Wonderful to have you here. The next person is me. So let us see what our good friend has to say about me. Okay.
EDU TV with 1 million eyeballs across the globe.
Connecting
ये
schools,
skip करना पड़ेगा
universities,
अगली बार में।
industries, and corporate houses.
Quantum mechanics hasn't profoundly shocked you, you haven't understood it. Greetings to all the esteemed guests, teachers, and all the viewers. I, Avni Chaturvedi, from class 12th of DPS Mysore, have been given the utmost honor to welcome Dr. Ramesh Sharma. Dr. Ramesh Sharma is the Director of Human Resource Development Center and a Faculty of Instructional Design and Chairperson of Committee to Facilitate Adoption of MOOCs for Swayam MOOCs platform of the Government of India at Dr. Bhimrao Ambedkar University, Delhi. He has taught educational technology and learning resources at Vamasai Open University, Malaysia.
This is quantum
He is an
computer.
expert in open and distance and
This one.
technology-mediated learning
Quantum
and
computer.
has served as a visiting professor at Universidade do Estado da Bahia, UNEB, Salvador, Bahia, Brazil, visiting professor at University of Fiji, Commonwealth of Learning as Director of the Commonwealth Education Media Center for Asia, New Delhi, Regional Director of Indira Gandhi National Open University, India, and Director of Distance Education at University of Guyana, South America. He has been a member of Advisory Group on Human Resources Development for the United Nations Conference on Trade and Development, UNCTAD. While at University of Guyana, he has also collaborated with UNDP for its enhanced public trust and security for inclusion. Volunteer Service Overseas, VSO, and United Nations Volunteer, UNV, to develop suitable education and opportunities for communities and youth. He is the editor of Asian Journal for Distance Education, launched in 2003, and has been associated with several other peer-reviewed journals, including SSCI and SCOPUS, and Distance Learning. An author-editor of several books and research papers on education technology, education media, and e-learning, Dr. Sharma is a practitioner promoting open university and open education resources, OER. He has been a trainer and capacity builder in the field of educational technology and
Okay, thank you, Avni. And now, thank you so much. Now, let us learn about the architect of this program today, our most beloved, respected Professor mmpant.
EDU TV with 1 million eyeballs across the globe.
Connecting schools, universities, industries, and corporate houses.
A very good morning to one and all present here. I am Avni Kothari from grade 12 Safari International School, Crossings Republic. On the account of World Quantum Day, I am truly enthused to introduce you all to our esteemed speaker for today, Professor M. Pant. Professor M. Pant is intimately connected with the IIT system, having got his PhD in computational physics from IIT Roorkee, having been a faculty for about a decade at IIT Kanpur, and a member of Board of Management at IIT Delhi for 6 years. He has also been part of the biggest distance learning university in India, the IGNOU. He has been an observer and practitioner of technology transforming education. He has been a Pro-Vice Chancellor at the Indira Gandhi National Open University and faculty at IIT Kanpur, MNLR Engineering College, Allahabad, and visiting faculty at the University of Western Ontario, Canada. His current interests are cognition, AI in education, and creating awareness of quantum technologies. He has also been a speaker at several TEDx events. It is my utmost honor to welcome you, sir, to enlighten us with your invaluable insights. Thank you so much.
Okay, thank you so much. Now, may I request Professor Suresh Chandra to give his opening remarks. And after that, I will request Professor P.V. Suresh to make his presentation. Thank you.
Thank you, Dr. Sharma. Actually, my job has been made a lot easier by introducing the speakers much earlier and about this. Can you? So I find a lot of young persons that I think from the present people. Because the education we had at that time moved a lot to the various things. And I will not think about quantum, but certain anecdotes may be helpful to you. As a student, which we learned, and later on, as a student of electrical engineering, you know the electricity passes, we say, through electrons and etc. हमारे एक प्रोफेसर मिश्रा जी हुआ करते थे, कहते थे ना भैया इलेक्ट्रॉन तूने देखा ना मैंने देखा, किताब में लिखा तो मान जाओ. तो वो that situation still remains. और फिर for my MTech, I was in the University of Roorkee. I think I remember correctly,
Arshne in physics. He used to teach us modern physics. I don't know why they include that subject for a master's degree. And I understand that he has worked with the Max Institute, Germany, and also in some physics institute in Russia. So that is the first time I was introduced to this Schrodinger's wave equation. He gave us an assignment. There was on the left-hand side and a right-hand side. From the left-hand side, we had to, you know all that. You have to prove you are given LHS and RHS. It was a, I think, integration kiya hoga. That was 3-level integration, triple. बड़ा मुश्किल था, हम लोग तो सुस्त थे नहीं किया. One of my colleagues or classmates, वो रात भर लगे रहे. तो लेफ्ट हैंड से राइट हैंड जाना था, वो फिर वापस लेफ्ट हैंड साइड पे आया. It proved that what he was doing was going through the right steps, नहीं तो वहाँ भी नहीं पहुँच पाते. तो एजुकेशन में ये होता रहता है. So one should not get worried about this. And another thing which I must mention, Dr. Varshne का तो हो गया. तो फिर बात आती है, आपने इलेक्ट्रॉनिक्स तो पढ़ ही रहे होंगे कुछ लोग, डाइट का भी पता होगा आपको. But I do not know how many of you might be knowing about tunnel diets. Tunnel diet का नाम सुना आप लोगों ने? ये बड़ी अजीब सी चीज़ है. अजीब in the sense, tunnel diet की थ्योरी वो क्वांटम से मिलती है. I'm not going astray from the subject. कि if some particle comes with a great force, it can penetrate through the wall or to the barrier. हम सब पढ़ रहे थे तो हमने कहा भाई ये कोई हज़ारों कारें आएँ किसकी इतनी होगी तो दीवार के पार भी जा सकती है. Practically yes. Then if there are number of them, some car may climb up the wall. That is called avalanche diet. अभी एक ही नाम से जाना है. And the invention of tunnel diet was done accidentally. Because the doping which in a Japanese institute, Lasky, was doing, उन्होंने ज़्यादा कर दी उसकी डोपिंग. तो उन्होंने नॉर्मली अगर आपने डाइट देखा हो तो रिवर्स करंट नहीं बैठती है. इट इज़ वेरी स्मॉल करंट विच फ्लोज. अगर इफ़ यू बायस द डाइट, ये 10वीं में मेरा ख्याल आजकल कराते होंगे आपको डाइट के बारे में. कराते हैं कि नहीं जो फिजिक्स पढ़ते हैं? दैट इज़ इफ़ यू फॉरवर्ड बायस एंड रिवर्स बायस. वो रिवर्स बायस में उन्होंने देखा एकदम करंट नीचे आ गई. तो एंड दैट टाइम आई रिमेंबर हिज letter to the editor, it was about a half a page, not even a half a page, half a column. उसके बाद सब डाइट, टनल डाइट में 20 किताबें निकल के आ गई. So what I'm trying to say, new things come, people get the ideas, and tunnel diet now has a lot of what you call applications in electronics. So those things keep on happening. And about, I think Dr. Datta mentioned about Cray computer. I met a gentleman, I think he must have been his colleague in DST, one Dr. Mishra. I met him in one of the meetings or a committee. I said, I like one thing about Cray very much. He said, what? The Cray used to say that it's a task given to you. It is very important to remember how these things are done. He said, I want it to be done in a specific time with the people available and the resources available. Don't ask me that I don't have this thing. Then Mishra told me he was a member of the committee which selected Cray computer. They had gone to buy that. Am I right, sir? He said, you do not know one thing more about him. And that's fantastic. He said that I'm going to establish this company or the facility at the village from where he had come. And in that village, nobody knew anything about electronics. There was one person who knew a little bit of soldering. That is the kind of dedication which you should remember. कि नहीं साहब हमारे पास resources नहीं, क्या नहीं करें. So Cray, who made first supercomputer, had that vision. So I am mentioning, people talk about supercomputer, but people don't talk about Cray, what motivated him. So this is the motivation which is very, very important. एक और छोटी सी चीज़. You have seen the tree, everybody of you. You only see the top. Tree actually grows in two directions, upwards and downwards. And it grows all the time. Your roots also grow all the time. Dr. Pant, Dr. Sharma, बहुत बड़े आदमी, वो knowledgeable है, but you do not understand the roots, that's the hard work and dedication which has gone beyond that. That's also important, that the roots should be strong enough so that the up portion of the tree also becomes. और एक छोटी सी बात और कहना, I cannot बुरा ना माने, क्योंकि इनका स्कूल जो है मैंने अभी देखा मोहाल इंस्टीट्यूट merit. He comes from a, I will not say tribe, from a Mohal people. Community, हाँ, that's right. इनके forefathers बगदाद में हुसैन के साथ लड़े थे, which many people will not know कि ये बगदाद में क्या कर रहे थे. आज का ज़माना और वो ज़माना बड़ा अलग था. कहा जाता है कि हुसैन की एक बहन मोहाल के फैमिली में जन्म में ब्याही हुई. उसने कहा भैया मेरा भाई जो है मुसीबत में, जाओ मदद करो. These are small, you see the word was very different what it was. Another small thing which I will also get. आप लोगों ने ये तो पढ़ा ना कि आईसी कैसे बनती हैं, डोपिंग करते हैं. डोपिंग करने का तो जानते हैं आप. जब आईसीज बनती हैं तो आप सबस्ट्रेट में या एन या पी टाइप की डोपिंग करते हैं. ठीक है, ये आज फिजिक्स पढ़ने नहीं पढ़ते आप लोग. चलो कोई बात नहीं. एक किस्सा आता है, कुरियन का नाम सुना होगा, अमूल का बंदा. उससे एक बार किसी ने पूछा तो भैया वहाँ क्यों नहीं जाता केरल में और डू समथिंग देयर. कहता देयर आर टू मैनी मलयालीज देयर. But it has a relevance. You see, when we dope, it is only one electron which goes and tries to find the place somewhere else. A covalent bond where there are only 4 electrons, वो वहाँ जाके किसी होल होता है तो इधर घुसता है. कहता है here I can, it's exactly the same situation. There are so many Malayalis, so there is no place there where you can move. So it happens in the real life also. You will find if there is a person where there are only people from one community and there is a person from another community comes, it outshines everyone. So ये छोटी छोटी जो I am saying it, we can relate these scientific things to the real life also. और क्वांटम में साहब क्या पंजी कहते हैं क्यूबिट्स, क्या रेक्टेंगलिंग बोलते हैं? नहीं जो इंटेंगलमेंट जो है. तो मुझे तो लगता है कि मैं जो 1962 में या 60 में था और जो आज हूँ, perhaps I am entangled with that. और एंटेंगलमेंट अब यहाँ आ गए तो पंजी के साथ हो गया. तो एंटेंगलमेंट भी जुड़ती रहती है मेरे हिसाब से. और मेरे को तो लगता है ये जो भूत है वो भी एंटेंगल्ड है हम लोग. Anyhow, thank you very much for enlightening.
Now may I request Professor P.V. Suresh to go ahead.
I'm sorry, I didn't say that.
So good afternoon to all of you. First of all, I would like to thank Professor mmpant for giving me this opportunity today in this particular prestigious event. And one pleasant surprise is the presence of students from the school. I am not aware that they are present. So my presentation was made in a different way. But then when we are facing students, we don't need to prepare anything, especially, because normally things become extempo. I joined IGNOU in 1997. I was taken into IGNOU by Professor mmpant, who was then director. And since then, until now, I was in touch with him. And his single mantra is that always be ahead. Today, whatever you are attending here on quantum computing, you will remember it more in the future rather than now. Now, many questions are unanswered, but you are hearing the word quantum computing and what all it can do. In future, you will be ahead of those children who did not attend or did not watch videos on quantum, because you know something about it. That something is your root, and it will enable you to grow many-fold in the future, that you don't need to read a book after this seminar or anything else. You attended it, it itself gives you some knowledge about this particular thing, and it definitely embeds in each and every one of your interactions with the society. When I say Professor mmpant always, though he doesn't say directly that you have to be ahead, not only in terms of technologies, you have to be ahead in everything. If there are any 10th standard, 11th standard, 12th standard students also, you must be knowing that your examination pattern has changed. Few days back, CBSE notified. Now you don't need to by heart much. 70% are multiple choice questions now. So you don't need to worry that you have to by heart and again start thinking logically if you have to crack a JEE mains or advanced. Now the preparation here was there also. Now you have to be ahead in the sense that whatever your teacher is teaching in the class, if she started a particular lesson today, don't try to revise what she taught you today. Now you came to know that she started teaching today and it will take 4 to 5 days for her to complete it. Today work hard and complete that lesson. Don't wait for the teacher to complete it. And tomorrow complete the exercises and exemplar. And before she completes the lesson, in parallel, keep asking doubts and get them clarified. Otherwise, you have to be in touch with her to clarify your doubts in exercises, theory and exemplar. By that time, she will be completing her second chapter. And this happens with every subject. You have 3 subjects, main subjects in your curriculum. So you have to be ahead in everything, each and everything. So this particular quantum computing will be taking you lot ahead, because supremacy of quantum computing was just proved by the Google. But then sir said that how many quantum computers are available in today? I think after 2 to 3 years, there may be 185 quantum computers available across the world. Today you have thousands of computers in some institutions, but quantum computers, after 2 to 3 years, the market is expected to have 185. So you can imagine the costs associated, the complexity of algorithms associated, and their application challenges. Because only when you are sure that it is going to solve your problem, you will buy it. Otherwise, you will not buy it. As on date, people know that it will solve the problems, but they do not know how to use it to solve their own problems. That is the reason why quantum computers are not available off the shelf. Of course, they are available from D-Wave, but one cannot just buy them and use them, because the programming, everything is very complicated, and first of all, you should understand how to program it. Today, since children are also available, I will run a video at last. I'll be brief, then I'll also run a video in which a student from MIT who is doing his PhD in quantum computing will give a presentation of 10 minutes. We can run it for 5 minutes. So quantum AI, it is a field that combines principles from quantum mechanics and artificial intelligence to enhance the capability of AI-based systems. We are only thinking of future of quantum computing. Now already people started speaking about quantum AI. Okay? AI took off. I studied AI maybe around 30 years back in my post-graduation. But now it has become a buzzword. And as one of our colleagues said that the prominence of degrees is going to reduce day to day. I do not know, most of you must have seen Elon Musk openly advertising positions to the people irrespective of the degree, background of the education and other things, with only one requirement that you should be good with machine learning. He said that if you are good at machine learning, you just apply, don't think about educational qualifications or anything else, and every month the team will have a meeting with me. Elon Musk will directly meet a team of 10 to 15 people picked from across the world who are good at machine learning, no formal education required. Of course, the people.
Age restriction is there or not?
Nothing. Nothing.
No, not for employment. I will do work without money. No problem.
Okay, so when AI is taking off, when quantum computing is a future, we are speaking about harnessing the power by applying the quantum computing principles to the artificial intelligence. So I think it is ahead. But still it is worth, because this is the place where reputed institutions are working. If you look at Stanford, if you are looking at Cornell, or many universities and top companies like Google, Microsoft, Amazon, they invest a lot into the future so that they can enter the market with such unique products that they will have the patent on it and they can make billions of it. So in classical computing, bits are used to represent information, either a 0 or 1, all of you know, a switch on or off. That is a famous example for binaries. But in quantum computing, quantum bits or qubits are utilized, which can exist in superposition of states representing both 0 and 1 simultaneously. This property allows quantum computers to perform calculations much faster compared to classical computers. Now, when you think of a computer, when Professor mmpant was there long back, when I joined, we used to have a computer that occupied the entire room. Wax machine. I still remember. We don't know where it is now. It occupies the complete room. Today, our mobile is very powerful. And I also met Ratan Dattaji at that time at his institution. And recently I got an opportunity to see the Cray in the Sector 62 Noida. And I have seen the Cray where you have put the image in the PowerPoint. That is now like a museum. They placed it there, but they have latest Cray. So I do not know if Ratan Datta can facilitate students to visit it, because many people don't know that we have a Cray in Noida. Very few people must be knowing that there is a supercomputer in Noida. Okay, so now you came to know that, look for an opportunity to go and visit there. It is a massive system. It occupies many halls. The processors are cooled with it looks like a lake. The water is fed. The supercomputer is cooled. Okay, it's like completely, many almirahs in a big hall. That totally makes up the supercomputer. Okay, if you cannot take a photo with a supercomputer, you have to take at multiple places. Then you should say that in totality, now I am with supercomputer. Okay, that is so huge. And that supercomputer may become at the size of mobile in future. And at that time, the supercomputer power will be completely different. So you always will have a computer of that size. You will always have a computer of this size also. Okay, so that is why we have to be ahead, because if you are good at it, you may become at this level, and you have to be staying ahead to be in touch with that level of the work also. So quantum AI, it aims to leverage this quantum advantage to improve various aspects of AI, such as optimization, machine learning, and data analysis. First of all, why we needed computers? Because speed. They can do things faster. Now, why you need quantum computers? Why people are behind quantum computers? Again, the primary reason is speed. Google, when it proved the quantum supremacy, it said that this particular problem, which was solved by their own quantum computer, must have taken 10,000 years if it is to be solved using the classical computers. So if you have to solve a problem that will take 10,000 years in few seconds or minutes, which can be done by a quantum computer, then definitely it will solve many of the problems. But there is a big danger. I do not know, I think some of you will know Y2K. I don't know school students whether they are born by that time or not. Okay. So
None was born.
That's what. Y2K created a big opportunity because across the world things have to be changed in a time-bound manner. They use 2 digits, 99, then becomes 00. But 1999 is going to become 2000. But their programming in those days put only 2 digits. So after 1999 means it is denoted by 99. And when it became 2000, it becomes 2 zeros. So when you are subtracting 00 minus 99 will crash the software. So entire software across the world which was developed using that structure has to be upgraded. That's what had given birth to Y2K problem, and I think 80 to 90% of the people of that particular age who can learn went to US. Because it is the US which is having a lot of software with that problem. Now what is going to happen with quantum computers is that the same is the situation. The reason is your security algorithms, which you are using for encryption today, they can also be broken provided if you give a million years for a person to try. Okay? Now let me say your password can only be one single digit. Then how many times you have to try? 0 to 9. 10 times you try, you cracked it. Okay? Now when encryption technologies are being used, they will take millions of years to break it. But with quantum computer in place, in no time your passwords will be broken. So once quantum computers become they have already become reality, but not at that level that it has become so much common and accurate. But once they become reality, world will be racing to replace the today's systems. Nothing is secure. Nothing. Because something 10,000, 20,000 million years can be just cracked in no time. So at that time, they will be needing many quantum programmers. Just like Y2K. You haven't seen Y2K. Since we have seen Y2K, we can imagine the rush that is going to take place when quantum computing takes over. At that time, people who are prepared will be getting the opportunities. In market, it's not the experience also. It's the skill which demands, skill with demand is going to determine your particular, means as a person how much you are in demand. Otherwise you say, I am working since last 40 years in this, but there may be no takers of it. Then you may become jobless if you are not in a government job. And you will be left without a job. So being ahead is very important, and quantum computing is going to create a tsunami as and when it comes. When it comes, we don't know. Okay, that is the magic. But when it strikes, you will not have time to vacate the beach. You will be just washed away if you are not prepared with the needed equipment. Tsunamis don't come by so much of warning early. Okay? So you need to be prepared for this particular quantum tsunami. So quantum machine learning algorithms, they utilize the power of quantum computers to enhance traditional machine learning tasks. For instance, a quantum computer could efficiently analyze large data sets to identify patterns and make predictions. Quantum algorithms like quantum support vector machine, quantum neural networks are being explored to handle complex machine learning problems. Due to the presentation that I have to give today, I prepared a lot which is not related to my topic, quantum AI, to create a foundation for myself. So, in machine learning, you have many algorithms, but it's not that machine learning algorithm you will be able to run on a quantum computer. You have to program again. for the simple reason that there they are zeros and ones, here they are qubits. And one thing which I learned from the YouTube about the quantum computing is that even these qubits can be apart. One qubit may be here and another qubit may be somewhere else. And ultimately, they are going to diverge to your classical computer. So people say that if you have a very big task, divide it into subtasks. Like that, a very big problem, ultimately after application of quantum computing, will again converge to a classical computing level problem. But that particular convergence is the biggest challenge. So quantum optimization is one thing, quantum cybersecurity. Now you just add quantum to everything. Whatever is existing, add quantum, because your computer's power is going to get changed. Your computers are going to get replaced. Maybe down the line, I don't know, AI I studied 30 years back, now it is in demand. Okay, quantum computing, 2019, I think Google had proved the supremacy mostly, if I am not incorrect. Maybe down the line, another 20 years, you may have only quantum computers on your desks. These computers will be in museums. Okay, at that time, what else is going to come up, we don't know. Okay, so those students who are into programming, try to do a bit of programming for quantum computers, then you may get a doubt, where is quantum computer for me to run a program? There are simulators available. Okay? Google is having the simulator, Amazon is having, Microsoft is having. For students, they may even offer freely. So whatever programming you do, at least run those programs that are already existing. There are many programs that are existing for quantum computers. You can simulate them until you get a quantum computer. That will give a feel of you how a quantum computer works. So this is one image, how the quantum works. First of all, again, as I said, everything you have to prefix with the word quantum. You prepare a quantum data set, evaluate the quantum model, then you take a sample from it, then you evaluate the classical model and evaluate the cost function. Then you have the gradients, parameters, which you need to update. The beauty is that in both artificial intelligence as well as quantum artificial intelligence, the brain of the programmer is very important. Because there are some parameters which the programmer sets. They don't have any particular logic. Like, let me say somebody here wants to go to washroom and they are visiting India Habitat Center first time, or this particular hall. One fellow will go this side, searching for it, another fellow will go that side. The fellow who went that side will take more time to reach this side because he will be querying 2 or 3 people there. The fellow who went this side will reach it faster, but why he went this side, nobody knows. And why this fellow is going that side, nobody knows. That depends on the individual's skill, cognitive skills, something which God created. So programming is like that. AI programming is more complex, that it depends on your brains to succeed. And again, quantum AI is also like that. Many parameters in your program are not defined. You have to give values to them. What value you give will determine the correct output. How much nearer to the output you are will determine your success. So normally these technologies are used at those places where 100% accuracy is not needed. They are not used in a flight navigation software, okay? Because there 100% accuracy is needed, nothing can go wrong. But at many places, if you are even 99% correct, it's okay. Because if you want 100%, you need 1,000,000 years or 1,000 of years to reach that accuracy. So 99% in few minutes is okay rather than waiting for 10,000 years for 100%. And then how the programmer sets the parameters will determine the correctness or accuracy of the program. That's the reason whoever is going into computers, they need to write algorithms first and write the program. They should never copy program. They should never copy the algorithm. But you always give your algorithms and programs to your friends, whoever asks them. Don't think that you are parting with something, nothing. You are not parting with anything. But you don't take anything. You have to apply your brain, write as many algorithms as possible, as many programs as possible. And your success means that in lab, how much little time you are spending. If you are spending little time and executing your programs, then it means that you have brains because you have done an algorithm at home and came and you have run the program directly rather than working everything in the lab. So I think time is running out. When there is opportunity, I will run the video because it's of 10 to 15 minutes. So I thank Professor mmpant and thank all of you for patient hearing. Thank you.
Dr. Sharma now. Before Dr. Sharma takes over, people talk about Dr. Finman. They talked about Dr. Finman. I will request all the young people here to read a book called You Must Be Joking, Mr. Finman. It's not about physics. It's about real life. आप ये किताब पढ़िए. And if you have also an occasion, it's available, should be available on the net. It's called a program called TRIZ. It was made by a Russian mathematician, Gulmohar, something like that. While in prison, at that time there were no big computers, no PC. That whatever mathematical knowledge was available till that time, he made a computer program. And you will be surprised to know that the theorem proving programs, which were the conventional, the computer gave a different, alternate answer. So please, अगर आपको मिल जाए, तो जरूर देखिए. It is the person in jail, what he could do. दो और बातें मैं शेयर करना चाहूँगा. Somebody mentioned about peer learning. Indian families are elsewhere all over the world. बच्चे लोगों के 4, 4, 5, 5, 6, 6 भाई बहन होते हैं. That was peer learning. Now when it's a nuclear family, that peer learning has gone. Because earlier the children used to learn from their generation. From their peers. So it's fact that peer learning is the most important thing. Another one thing I will शंकराचार्य जी का तो सभी ने नाम सुना. और हम कहते हैं टीचिंग मेथड क्या होने चाहिए, क्या नहीं. बड़े रिसर्च होते हैं. Have anybody wondered here? Shankaracharya died at the age of 32. And in that 32 years, he wrote books, traveled all over the country from Kerala to Kashmir 2 or 3 times, and taught people out. No internet, no electricity, no computer. So how he did it is a matter of research. पैदल चलते थे. अब हम लोगों के पास पैसे भी हैं, सब कुछ है. मैंने तो कन्याकुमारी से कश्मीर. He would travel 3 times on foot, wrote books, and taught people. And that's very important. That is how we have to do. Another thing, I do not know whether this quantum computer will ever be able to do. गणेश जी का नाम सभी ने सुना. गणेश जी की एक खासियत शायद पता. When Ved Vyas was dictating to him, anybody remember? क्या थे उनकी शब्द? No, that's not important. वो तो stenographer भी करता है. He has to understand what is being said, and you know that most of the words have double, triple meanings. तो वो कंप्यूटर तो आज तक नहीं हम बना. मेरे ख्याल से बनेगा भी. जो बनेगा वो वेद व्यास को वो शर्त नहीं थी कि आप हाँ हाँ तो ये जो है दिस इज मैं उन आप ठीक है गणेश भगवान जी की पूजा करने से ये उनका जीनियस था मुझे नहीं मालूम है वो कंप्यूटर थे क्या क्या तो ये सोचिए कि आपको भी कोई ऐसा बनाना है कि अभी भी जब हम कंप्यूटर प्रोग्राम करते हैं सिंटैक्स वगैरह चेकिंग करते हैं पर ये तो कोई नहीं चेक करता कि वो ठीक बोल रहा है कि नहीं बोल रहा। मैं ये कह सकता हूँ कि बिल्ली जो है पेड़ पे की बजाय दीवार पे चढ़ गई काली बिल्ली नहीं थी लाल बिल्ली थी लाइक दैट तो कंप्यूटर तो मान लेगा कौन गणेश जी अब उस समय तो था नहीं ना सर तो इस तरह से व्हाई आई एम ट्राइंग टू टेल यू दीस थिंग्स कि अपना दिमाग खुला रखिए
डॉक्टर सुरेश ने कहा था बच्चे जाना चाहते हैं
So it's very important what you are listening to, but believe me, don't worry and don't be intimidated by all the 10 साल के बाद पता नहीं क्या नई चीज आने वाली but you have to be prepared to understand what is going to come. Thank you.
Okay, thank you, sir. Okay, now it is the time for understanding quantum biology. Yes, quantum biology. So far, there has been some sort of a skepticism that quantum, when we say, it's a field of mostly the physics, and since it deals with atoms, electrons, protons, neutrons, all those subatomic particles, so it goes with the chemistry. And when there has been even that doubt was at MIT level also, the elite group which considered themselves as the experts on everything, and when they read a paper by some colleagues from UK, and they laughed about it, that how biology can be related to that. And there are some interesting things happening at that time and even now. But before that, when Karthik was explaining about the National Quantum Mission, he said about atomic clock. And at that time, I remembered that nowadays everybody wants to go to moon. And you may be perhaps aware that the United States, the government there, they are planning to have the time zones for moon different about it. And they are planning to have one atomic clock especially there for moon. So these things, they are happening. The most interesting thing about it that there are some fundamental questions about like what is universe, how it evolved, what is life, means what is the difference when everything is made up of atoms, electrons, protons, neutrons. We as living beings and this dead material, water bottle, this mic, everything. If you cut them, keep on, ultimately what we will be having, the smallest unit as the atom. And when everything is there, what makes us different than these things? So what is life? Ultimately, some philosophers like Socrates and other things, they said that, okay, it is the consciousness. But then what is consciousness? If you see in our human body, where does that? Similarly, like soul or those things. And the interesting thing here is that at nature level, you have seen all those photographs of quantum computers. They don't look like a computer. They look like more or less as a chandelier. And all those tubes, they are the cooling tubes to keep it cool. Because it believes that when we say quantum coherence, as Professor Suresh Chandra was saying, and entanglement, it is quite an interesting phenomenon that suppose now in a city, the police department got a news that there is a thief out there in the city trying to steal something from the properties of people. Based on this information, police is trying to find that person. So That person can be in Kamla Nagar, in India Habitat Center, maybe in Sector 62 Noida, trying to steal away the Cray computer, or maybe in the house of Professor P.V. Suresh in Ignu Medan Gadi, anywhere. You don't know. It can exist anywhere. But as soon as the police, they come to know that the thief is in India International Center, and everything then gets cleared. All other options, they get closed. This is called as collapsing of all these things. So when we say that the entanglement, the quantum, the electrons, we don't know the location. But as soon as that is fixed, it collapses the system. Now, to keep these things, we need to keep our computers super cooled. And that's why this is huge infrastructure for the quantum computers. It is needed for that. So, but at nature level, there is no such mechanism. The photosynthesis which happens in the plants, it is at the room temperature or natural, where it can be harsh conditions up to say like 40, 30, 47 degrees Celsius in Thar deserts, or maybe in the Himalayan regions, the plants are still there with the 0 or sub-zero temperatures. There we need the unit, smallest unit of a living body, the cell, the smallest unit. But cell is also a very complex structure. It has so many organelles inside it, which keeps on working day and night, reproducing, dying, then creating another thing. The example, the answers to that, the classical things, the classical theories, they are not able to give the proper answer. So it is believed that the quantum computing can help us in solving the problem. So I have made a short video about it, thinking that if we keep on speaking, maybe take more time. We will understand the importance So and let's have a relevance look of at it. studying quantum phenomena in biological systems. Classical biology, which is a natural science, is the study of living organisms, which covers many specialized fields like physiology, anatomy, morphology, while broadly dealing with study of plants, that is botany, and study of animals, that is zoology. Quantum biology is the study of how the principles of quantum mechanics, that is the physics that governs the behavior of atoms and subatomic particles, play a role in biological processes. Quantum biology illustrates how the concepts of physics, chemistry, and biology are relevant to the understanding of life's molecular processes like photosynthesis, enzyme catalysis, and even our sense of smell. Migration of animals, maybe marine or avian, had been a mystery for a long time. Scientists now have evidence that it may involve quantum effects, allowing migratory birds like the European robin to sense, that is hear and see, Earth's magnetic field. As more and more research is being carried out, our understanding about fields like biotechnology, nanotechnology, and even quantum computing itself is becoming clear. So here, we would focus on exploring the potential of this field to our understanding of natural world and the interplay between quantum mechanics and biological systems, which can help reshaping industries like energy, medicine, and computing. It may seem strange to think about quantum effects being relevant at the scale of biology, but there is a growing evidence that quantum phenomena can influence things like photosynthesis, enzyme catalysis, and even our sense of smell. Here is an example from daily life that illustrates a quantum biological process. When you smell a nice aroma like freshly baked bread or blooming flowers, you are actually detecting molecules in the air through a quantum mechanism. The molecules that create these smells interact with specialized proteins called odorant receptors.
Beings can distinguish more than 10,000 different smells. The organs of smell are hidden inside the nose. As odoriferous molecules contained in the air that we breathe enter the nose, the olfactory receptors emit a neural message. This message is carried via the skull to the olfactory bulb, a nerve structure that relays the information to the cerebrum. The conscious representation of perceived smell is generated in regions deep within the brain. Since some of these regions are also involved in memory, a single smell may instantaneously evoke a past event.
So, rather than just fitting together like a lock and key, these molecules vibrate in specific ways due to their quantum energy levels. The odorant receptors can detect these quantum vibrations, allowing you to perceive different smells. So in this case, the ability of your nose to differentiate between different odors relies on sensing the quantum vibrations of the odor molecules. This quantum phenomenon occurring at the molecular scale is being detected and processed by biological systems in your body. So, while quantum biology is a nascent field, it shows how quantum physics can be just as relevant in understanding life's molecular processes as traditional chemistry and biology concepts. So, let us understand about quantum biology. It is a relatively new field that has emerged over the past few decades. It explores how the unusual, counterintuitive principles of quantum mechanics may play a role in biological processes within living organisms. For a long time, it was assumed that quantum effects would only be relevant at the microscopic scale of atoms and molecules. However, researchers have discovered tantalizing evidence that biological systems can harness quantum phenomena at larger scales to carry out important functions. So, while classical Newtonian physics and chemistry can explain much of the biological world we observe, there appears to be instances where the rules of quantum mechanics become incredibly important, even in large biomolecules and cellular processes critical for sustaining life. This raises profound questions like, could quantum coherence and entanglement represent untapped biological principles of organization? And do deeper quantum phenomena underlie the remarkably efficient machinery of life itself? Quantum biology promises to shift our perspective on the fundamental building blocks of the living world. One of the most well-suited examples of quantum phenomena in biology is the process of enzyme catalysis. Enzymes are biological catalysts that dramatically speed up chemical reactions in cells. However, the rate enhancement they provide cannot be fully explained by classical physics alone. Experiments and theoretical models indicate that an effect called quantum tunneling plays a key role. Quantum tunneling allows particles to tunnel through energy barriers more easily, effectively bypassing the obstacles that classical particles could not surmount so quickly.
The amazing process of photosynthesis.
Striking example comes from
A look around at
photosynthesis.
nature is an absolute treat to our senses.
The process by which
We
plants,
all enjoy
algae,
the colors and
and some
fragrance of
bacteria
plants,
harvest sunlight to
but
produce
seem to
chemical
forget
energy.
about their important contribution. Plants are an absolute necessity for life on Earth. It is so because of the process of photosynthesis. A closer look at a plant shows that it is firmly held in the soil by the help of roots. These roots absorb water from the soil and through the tiny tubes transport it to the stem and then to the leaves. The stem holds the leaves in such a way that they absorb maximum energy from sunlight. A leaf is a very important part of the plant. Photosynthesis, the ultimate provider of food and oxygen, occurs in the leaf. A leaf consists of a flat, thin lamina, which is joined to the stem by a petiole. The flattened lamina provides large surface area for trapping sunlight. cross-section of the leaf shows the upper and lower layers of cells, which are flat and irregular. Below the upper layer is the layer of tightly packed cells. These cells have specialized organelles called chloroplasts. Chloroplasts contain the pigment chlorophyll, which gives the green color to the leaf. The next layer has loosely arranged cells with large air spaces. This section also shows tubes specific for transporting the absorbed water into the leaves.
So, as you have seen here, the extremely efficient energy transfer in photosynthetic complexes has been proposed to rely on quantum coherence effects. Quantum coherence involves the wave-like behavior of particles where they can synchronize their motions in coordinated patterns. This coherence may help shuttle energy with near perfect efficiency from the light capturing pigments to the reaction centers that drive photosynthesis.
This is a European robin. I've been underestimating it.
Even more amazingly, birds like you just saw, like the European robin, appears to harness quantum entanglement to navigate using the Earth's magnetic field through a sense called magnetoreception. Quantum entanglement is a phenomenon where particles exhibit instantaneous correlations with each other even when separated. In bird magnetoreception, it is thought that entangled pairs of electron spins in light-sensitive protein molecules allow the birds to literally see or sense the Earth's magnetic field lines, providing a quantum compass for migration. This is just one illustration of how evolution might have harnessed quantum effects for biological advantages. Watch this small demonstration.
My entire life. You see, some of these birds migrate from the UK to the tip of Spain and back without losing their bearing. And the way they do it is incredible.
They don't use regular GPS or Google Map like
I
us.
rely heavily on technology to get me places.
We depend on technology.
Unlike me, robins are natural navigators. So much so, they've been dubbed sailors of the air.
They are
So,
sailors
with the
of
help
the air.
technology, I tracked down these aviation experts to examine them up close and personal.
So, at the most fundamental level, even the building blocks of life like DNA and proteins exhibit intrinsic quantum vibrations and motions crucial for their structure and function. Some scientists have proposed that these quantum oscillations play an important role in biological information transfer and cellular signaling networks. But how can researchers actually detect and verify these proposed quantum phenomena in real biological systems? A range of cutting-edge experimental techniques have provided key evidence over the past few decades. Spectroscopy methods like nuclear magnetic resonance (NMR), electron paramagnetic resonance (EPR), and X-ray crystallography have revealed that quantum signatures when probing biomolecules at atomic resolutions. For example, careful designed NMR experiments analyzing spin dynamics have revealed signatures of quantum entanglement between electron and nuclear spins in protein complexes involved in migratory bird navigation. In the case of photosynthesis, pioneering experiments in 2000 used sophisticated laser pulse technique to demonstrate long-lasting quantum coherence effects during the critical energy transfer steps. By analyzing the oscillations in ultra-fast laser spectroscopy signals, researchers gathered compelling evidence that quantum wave-like motion facilitates this remarkably efficient process. However, verifying and isolating these proposed quantum effects experimentally is incredibly challenging. Biological molecules exist at warm, wet, and noisy conditions, very different from the cold, isolated vacuum environments that are optimal for preserving delicate quantum states. This makes it difficult to definitely rule out alternative classical explanations in some cases. More advanced techniques and quantum control methods for complex biological samples are still needed for unambiguous evidence. To better understand and interpret the growing experimental data, theoretical physicists and computational scientists have been developing sophisticated quantum mechanical models of biological processes and systems. These models treat biomolecules quantum mechanically, accounting for wave functions, coherence, and entanglement between particles. The models aim to simulate the full quantum dynamics of energy and electron transfer pathways based on the structures of real biological complexes. For instance, scientists can input a high resolution protein structure and study how quantum effects between different chromophores, which are light absorbing molecules, could enable highly efficient energy transport during photosynthesis. Similarly, models of quantum magnetoreceptor proteins allow testing hypotheses about how photon absorption and entangled radical pairs produce magnetic field sensitivity for the bird navigation sense. Specialized quantum biology software platforms like Quantera allow researchers to input molecular structures, run quantum dynamic simulations, and analyze things like energy transport rates, reaction pathways, and decoherence timescales. However, accurately modeling large molecular systems with thousands of atoms is immensely computationally intensive. Simulating the full quantum dynamics and interactions become exponentially more complex as system size increases. This is where future advances in quantum computing hardware could prove transformative. Quantum computers could potentially simulate these biological quantum systems far more efficiently by harnessing quantum parallelism that classical computers struggle with. As our understanding of quantum biology grows, the potential applications become increasingly exciting to consider across fields like biotechnology, nanotechnology, and even quantum computing itself. In biotechnology, insights from how photosynthesis capitalizes on quantum coherence effects could inspire designing artificial light harvesting systems or reaction centers for applications like biofuels or biosensors that operate at unprecedented efficiency. At nanoscale, researchers may seek to engineer molecular structures that leverage quantum effects like electron transport or entanglement for applications in quantum computing components, communication, or cryptography. Quantum biology could also feed back into how we approach quantum computing itself. If biological systems have evolved workarounds for maintaining robust quantum coherence even in warm, noisy environments, perhaps those design principles could inspire more scalable and fault-tolerant quantum computer architecture. Looking even further, some scientists have speculated that any system capable of replicating itself with maximum efficiency and fidelity may require harnessing quantum coherence and entanglement as fundamental operating principles. This raises the question of whether a quantum observer ability is an essential requirement for life itself with profound implications. At the most fundamental level, mapping how quantum phenomena exist as an intrinsic feature woven into biological processes could spark a big shift in how we view workings of the natural world and the roots of how life emerged. After being long relegated as only relevant at the atomic scale, quantum physics is now being explored as a critical link for understanding core biological functions and the remarkable efficiency of living systems. from quantum tunneling in enzymes to coherence in photosynthesis to entanglement enabling magnetic senses. We are discovering pockets of the quantum realm thriving within the biological world. While still an emerging field with many open questions, quantum biology represents a true interdisciplinary crossroads. It combines the methods of biology, chemistry, physics, and computer science to unravel nature's deepest quantum-driven mysteries. As our experimental techniques and computational modeling capabilities grow more advanced, quantum biology promises to upend our preconceptions and reveal new insights about the great role that bizarre quantum effects may play as an untapped organizational principles of the life itself. Thank you so much.
So basically the point here is that ultimately how we can examine the behavior of subatomic particles as it is happening in our live cells, that is the biological phenomenon. Because the traditional sciences, there are some things which is not quite clear to us how it is processed. So that's the field of science, and it's very good for our students that they can have the think about the career opportunities it offers for their future. Now I'll request Professor Pant to.
I'm not giving a lecture and I'm not responding to this. What I am going to do is try to tell everyone, there are a lot of students, others may be parents and so on, why quantum is so fundamental and why all normal streams, I think in school you say, I think science non-medical, science medical, then commerce and arts. Because now we are moving and these things you've seen, I just want to say why all four streams should see as quantum changing their lives. Now for physics or what is called non-medical, you all understand it's quantum computing. That National Quantum Mission, Karthik Verma gave you all the examples, so you know what is headed in that. For the medical stream, Ramesh Sharma has indicated to you about quantum biology, but when you look at the bigger vision, you realize that, and I dare say this, that all future advances are going to be in the medical stream, in quantum. And in fact, more in general physics itself. And I'm saying this with first-hand experience. During the last year, I had to go to the hospital several times. And as I went through the hospital, most people get worried, but I was so excited. X-ray machine, then ultrasound machine, then MRI machine, then I was in a physics lab. It was a physics lab for human beings. Now, MRI, nuclear magnetic resonance, electron spin, etc. More and more we will learn about the body from all these things, and now already in England they have taken a decision that the big MRI is not going to be there. They'll put a small quantum sensor, and from that they will see things like that. So the new generation of doctors are going to be actually not distributed. In fact, let me put it more bluntly, we are now going to start dealing with physics of living systems. So far we were only dealing with physics of dead systems. So everything we did in a physics lab was dead systems. But now we'll all be talking about physics of living systems, and it's the same quantum thing which cuts across. Now, about the commerce stream. You heard that the person who talked about National Quantum Mission was from the commerce stream, but Suresh talked about so much. He talked about Y2K as the big opportunity which happened in this thing. There's a similar word called Y2Q, years to quantum. Y2K we knew exactly that it is 2000. Y2Q is years to quantum, which means when the first good quantum computer will already be there. And the reason is, and I must go into this bit of detail, all security today that you have is based on some cryptography, most famous is called the RSA algorithm, after the three people who made that. The RSA algorithm is based on the premise that of what is called a one-way function in mathematics. So what one-way function means in mathematics is that you can do something, but you can't do the inverse. And the simplest one-way function for all of you is multiplication. You can multiply any two numbers given enough time, no machine needed, just you can multiply any two. But finding the factors of two numbers is extremely difficult, especially if the factors are prime numbers. So RSA 129 happened because these people, these three people, they took a 64-digit prime number, a 65-digit prime number, multiplied it, got a 129-digit prime number, declared it to the public, and said, can you factorize this? And that is what led to RSA 129. Today, what people use in practice is RSA 2048. And this is why, as Suresh said, this was unbreakable. And all this thing, blockchain, this, that, we are getting this. That, with the Shor's algorithm, is now breakable. The algorithm is there, but the computer isn't there. Actually, smart people are already collecting data that when the computer comes, they will decrypt it. Right? So they're already collecting. And a whole set of people are going post-quantum cryptography on that. So this is the... Now you might say, what will the arts people do? Arts people will write fiction about quantum computers and the machine having computers, etc. One country having a quantum computer, the other country not having a quantum computer, this country winning against that, and so on and so forth. So all this Sherlock Holmes, etc., you can create all kinds of fiction. And imagine a fiction, somebody extraterrestrial, somebody from Mars. In fact, long time ago, there was a book, Men Are From Mars, Women Are From Venus. Now you can actually create characters from this thing, and you can imagine that Mars person has a quantum computer, the other person doesn't have a quantum computer. What do they do? And so on and so forth. So all that I'm saying is this opens up a new area for everyone to take interest, sharpen their skills, and move on. I could talk about real quantum at some time, but now I think lunch is more important, and we should therefore look at having lunch. And I'm very happy to interact with all of you. I'm on social media. I post something on LinkedIn more or less regularly. I may copy the same thing on Facebook. I do that. I have a site, mmpant.com. I put a blog. I'm not on TikTok. So you can't find me.
For example, quantum computing itself is based on quantum mechanics. Okay. So, in mathematics, one-dimensional, two-dimensional, three-dimensional, when you read theorems, they go to n-dimensional. So we used to ask our teacher that, sir, what we will do with anything beyond 3 dimensions? 3 dimensions are visible, But now you are asking us to prove for n-dimensional. Why we should do it? What is its application? He said that it is your job to find the application. Theory was developed, now it is your job to find the application of n dimensions. So physics was developed, and again theory to the physics is being added every day. Now the implications of the physics to the computers, quantum mechanics we all studied long back. But today in quantum computer is coming. Its application is coming now after many decades. So with the new theories that are going to get developed, what is going to come again is in our hands, and no subject is limited. Always there are additions.
No, two questions for Dr. Sharma. Is there any question?
Okay, thank you so much. Be back by say 2:15. It's already 1:30, so we are saving time. Thank you. ठीक है. Hello, welcome back. Let us begin with session 2, raising a quantum ready workforce. May I request the presenters of this session to please come here. Rahul ji, Mr. Rahul Agarwal, Dr. Bhavna, Dr. Sunil, and Dr. Gurpreet Kaur. उनका इंट्रोडक्शन करना है. So, thank you so much. We are beginning the next session, raising a quantum ready workforce. And we are happy to have all of you here. Thank you so much for joining us. Mr. Karthik Sharma is the chair for this session, and we have a small AV on him. Let's learn more about Mr. Karthik.
To have the opportunity to speak to you today. I am from GK Gurukul, currently studying in 12th grade. It is my pleasure to introduce Kartik Sharma sir, a distinguished technology individualist with over 15 years of experience with over developing innovative technology products. His expertise lies in AI, particularly in creating conventional boots RPA solution using machine learning. He is co-founder of Deco AI, now a part of Bright Camps, where he established the AI and coding curriculum for a company, backed by GSP Ventures, Premji Invest, and others. Leading AI product initiative for Mafatla Group, sharing the AI educator task force with Course HQ supported by the Minister of State for Artificial Intelligence, Digital Economy and Remote Work Application Office, mentoring over 25 startups and investing in companies like Ziv Electric, NewMe, and CityPro, serving as a mentor in the Stanford Seed Spark program and contributing to the AI Readiness initiative of the Department of Scientific and Industrial Research, Government of India. involvement in various estimate organizations such as the All-Party Particular Groups on Artificial Intelligence in the UK and AICCIE Tech Task Force in India. Membership in leadership roles at institutions like Steve Jobs House, Windsor House, UK, AAIM Young Leaders Council, and the Board of International School of Artificial Intelligence UK. Contribution to education programs in India, including being on the academic committee of AI course for Dr. APJ Abdul Kalam Technology University. He worked as a world member with the management and entrepreneurship and professional skill council. His networking projects such as conducting maturity assessment for Dubai Electricity and Water Authority and writing educational book on AI for CBSE curriculum in India. He is the silver medalist of prestigious Indian Institute of Technology and his extensive experience, academic achievements, and contribution to the field of technology and education make him a truly valuable asset to the industry. Thank you.
We have with us Mr. Rahul Agarwal. There is a small AV on him.
Thank you, sir. Quantum physics, where the mysteries of the universe unfold, revealing the astonishing dance of particles and the enigmatic tapestry of reality. Greetings, esteemed viewers and eager learners. I am Ishani Sarkar, one of your hosts for today's enlightening session. Hailing from the prestigious Delhi Public School, Siliguri, I stand before you as a 12th grader. Having had the privilege of guiding as one of the house captains in my school council for the past year, with a fervent dedication to both scholarly pursuits and extracurricular endeavors, it is my utmost honor to introduce our esteemed guest speaker, the illustrious Mr. Rahul Agarwal. Together, let us delve into the depths of education and embrace the wisdom he has graciously agreed to share with us today. Mr. Rahul Agarwal is an engineering leader with more than 25 years of experience in development of complex products involving software and hardware. Science is spread over geographies including Finland, Germany, Italy, France, United Kingdoms, United States of America, China, South Korea, and Vietnam. He has led programs in diverse technology areas including cloud, SDN NFV, DevOps, Datacom, satellite, and telecom. He has led creation of innovations with multiple proofs of concept like Cloud RAN, Instant VPN, EVFC, and more that were demonstrated at MWC and other shows. He is a bachelor's in computer science and engineering, postgraduate in technology management, and diploma in cyber law. He has worked with HCL, CDOT, Hugh Software System, Flextronics, Aricent, Altran, and 3SR Consultancy. His current interest areas are neuroscience, cybersecurity, and quantum technologies. He has written articles on various topics and is also deeply involved in creation and delivery of learning programs for students and professionals. He is the abstract for the talk that Mr. Rahul will share with us today. The talk will cover the evolution of quantum technologies from their foundations in quantum physics, including key milestones like the introduction of quantum hypothesis by Max Planck, the first quantum revolution leading to the technologies like lasers and transitions, challenges to quantum mechanics by Einstein and other scientists. We welcome Mr. Rahul Agarwal.
Thank you. We have Dr. Bhavna Chibar, Principal of Laburnum Public School in Gurgaon. Let's learn about her.
The fabric of space-time to the GPS on your phone. The universe speaks the language of quantum mechanics. Greetings, ladies and gentlemen. I warmly welcome you all to celebrate World Quantum Day. World Quantum Day is an annual celebration promoting public awareness and understanding of quantum science and technology around the world. This is Shaila Datta, a proud learner from the IBDP wing of Delhi Public School, Ghaziabad, Meerut, an IB World School. I am currently pursuing Year 2 of the International Baccalaureate Diploma program. I feel honored today to introduce our our esteemed speaker, Dr. Bhavna Chib. Dr. Chibber brings over 25 years of dedicated service to the Indian education sector. A seasoned professional, she is passionate about fostering authentic learning experiences for both students and educators. Her expertise spans across various areas: academic operations, technology integration, to people's management, all of which have played a key role in establishing exceptional learning environments. Dr. Chibber's leadership extends beyond the classroom. As a dynamic school principal, she has spearheaded initiatives in total quality management, ICT implementation, and cybersecurity. Her contributions are widely recognized. She has not only received numerous awards and accolades, but has also authored course books and educational publications, and even played an instrumental role in formulating the ICT curriculum with NCRT. Dr. Chibber's commitment to education goes beyond policy. She actively facilitates teacher training programs at all levels and training all stakeholders, teachers, students, and parents in collaboration with CBSE, NCRT, and other leading institutions. Dr. Chibber isn't just a leader, she's also a passionate educator. Her vibrant personality and strong leadership skills shine through, as seen in the authorship of her book, Cyber Pen. With a profound commitment to education and a wealth of experience, Dr. Bhavna Chibber continues to inspire and lead the way towards excellence in the Indian education sector. With this, I would like to invite Dr. Chibber to share her insights about World Quantum Day.
So, next we have Dr. Sunil Pandey. He will be speaking for the students of computer science.
Universities, industries, and corporate houses.
What quantum mechanics teaches us is that everything we call real cannot be regarded as real. Greetings, everyone. My name is Aditya Rao of Class 12 from the Dean's Academy, Whitefield, and I'd like to thank all of you for joining us in this gathering on the occasion of World Quantum Day. World Quantum Day is an annual celebration promoting public awareness and understanding of quantum science and technology around the world. I'd like to thank EduTV for giving me this opportunity to present and introduce you to our speaker, Professor Sunil Kumar Pandey. Dr. Pandey holds a PhD and a DSc in computer science and has nearly 3 decades of experience in the industry and academia. He's a TEDx speaker on the topic of decision making, having an interest in cloud, blockchain, database technologies, and soft computing. He is credited with 12 patents, 1 copyright, and has published 60 plus papers and 7 books. He has authored numerous articles and interviews in different online and print media. Dr. Pandey is a recipient of several awards and recognitions in India and abroad from DataQuest, Business Standard, Enterprise IT Magazine, and numerous other prestigious institutions. Dr. Pandey has been a regional coordinator of CSI. He is a member of the prestigious CSI Communications and is associated with various professional organizations in the field, including IEEE, ACM, and several others. I would now like to hand it over to our esteemed speaker, Professor Sunil Kumar Pandey, to take over.
Thank you. And we have Dr. Gurpreet Kaur.
I am Mehak Aisha Sohan, a grade 12 student studying at Abu Dhabi Indian School, Abu Dhabi, UAE. I would like to thank EduTV for this opportunity, and I am excited to expand my knowledge in this field. And with that, I introduce a true luminary in the field of educational technology and innovation. I welcome our speaker for the day, Mrs. Gurpreet Kaur Ma'am. With 25 years of experience in the realm of education, Ma'am has seamlessly transitioned from being an educator to a mentor, an edupreneur, and finally to an IT thought leader. Ma'am has made an inedible mark on education through multifaceted contributions. Her passion for shaping the future of learning is evident in her instrumental role in formulating IT curricula across all levels of education. Not content with simply crafting curricula, Kaur Ma'am actively engages in training teachers, students, educational leaders, and parents, ensuring that they are well equipped to navigate the ever-evolving landscape of technology in education. As a prolific author, Kaur Ma'am's expertise shines through in her numerous publications in the field of IT, which have been utilized by prestigious educational organizations such as CBSE, NIOS, and NCRT. A vast array of certifications, including Google Certified Educator, ICDL Certified Web Editor, Oracle Certified in PL and SQL Programming, Microsoft Certified Trainer, and Adobe Creative Ambassador further attest to her expertise and dedication. Her journey exemplifies the notion that age is just a number, as she continues to inspire with her wisdom, confidence, and eagerness to embrace new challenges. Ms. Gurpreet Kaur Ma'am is not just an educator, she is an educational evangelist, tirelessly working to empower educators with the skills and knowledge needed to thrive in an increasingly data-driven and AI-driven world. Without further ado, let us extend a warm and enthusiastic welcome to Mrs. Gurpreet Kaur Ma'am, a beacon of innovation and leadership in education. Thank you.
Thanks to our students for this wonderful introduction of our speakers. May I now request Mr. Karthik Sharma to make his initial remarks. And after that, we have some students expressing that why studying of quantum is necessary for them.
Thank you, sir, for the kind introduction. And it's great to see on a Sunday afternoon so many people passionate about learning around quantum. And I'm grateful to you, Pan sir, who's our mentor, to put together such a passionate group on quantum technologies. When the world is talking about AI and just catching up with it, sir, as a visionary, as always, is just thinking 2 steps ahead and getting people together. I was just researching globally as of now, maybe 15 or 20 conferences a month are happening compared to thousands around AI. So we are lucky and fortunate to be in an AI quantum conference when the number is just 15, 20 around the world. And to be able to put together, I think almost single-handedly, sir has put it together. So we are really grateful to you, sir, and honored to be part of this forum. I think I'll just take a couple of minutes to set the context, and then we have some students coming in, and I'll invite my panelists as well. I think a few years back, we had a similar conversation around AI, that how AI-ready workforce needs to be prepared, how we need to prepare and skill people on AI. In fact, on my way here, I was chatting with somebody and saying that I'm going for a chat on quantum. And he said, yeah, AI padhna hai ki quantum padhna hai? Like, you usually talk about AI, now you're talking about quantum. Padhne ki zarurat kya hai, AI or quantum? So this is what an average person thinks right now, that what is relevant to be learned. Few years back it was coding, then it became AI, now there is quantum. So students here might be confused that what do we really need to learn to be relevant in the workforce from now? And I think any technology worth its while becomes more relevant when it becomes a B2C use case. So all technologies start from a B2G, then B2B and B2C. Like if you talk about computers, computers were there since 1930s. But when PC came, then it became more and more relevant. Similarly with smartphones, with AI. I mean, companies have been working on AI for the last 40, 45 years. But thanks to ChatGPT, suddenly it becomes a household name and the skilling demand increases. So I think for quantum, that ChatGPT moment has still not happened. So it's still very B2B, very niche, very sophisticated when anybody talks about it. It's still not a household name. In fact, I was researching in terms of the job count, less than 3,000 jobs, active jobs in quantum, compared to 150,000 in AI right now. So suddenly when you talk about relevance, people always look at the number of jobs. Do I really need to invest in skilling myself for a job in next few years? But that number is projected to become by 2027 close to 100,000. From 3,000 to 100,000 jobs in quantum will emerge globally in next 3 years. And according to a McKinsey study I was reading, right now for every 1 job, only 0.3 skill, like 1 in 3 is available right now. So 3 jobs, only 1 person is available as of today. So there is a good expectation from a demand perspective and supply. So this supply demand equation is extremely skewed for quantum right now. So people who are early adopters, it's a good time to get into this space right now. And thanks to what's happening with Google Quantum AI, TensorFlow Quantum being developed. So the ecosystem is also shaping up for a wider and faster adoption of quantum. So I think it's an interesting space to be in. And today we are lucky to have panelists who represent schools, universities, corporate L&D, all three. And I think all three have different challenges. Schools typically tend to look for some sort of handholding and advice from regulatory bodies to give them some sort of a framework, handbook, guidance, create a proper subject, and that's when schools get into action. If you look at universities are very straightforward, driven by industry. If there is a job opening, if there is a steady supply of potential skilled resources needed for a technology, universities very quickly step up the game and create programs and courses around it. If I talk about corporate L&D, now Gurpreet ma'am has switched loyalties from school to corporate, and corporates typically operate very straightforward. Like as long as there is economic benefit of a particular technology, whether as a vendor partner or ecosystem enabler, they would start investing in it because they look at a higher billing rate for a resource if they are higher skilled. So it's a very easy business case for corporate. But we'll get into more details with each of our stakeholders and see what are the challenges of their field in terms of promoting quantum. And the format we'll do is we'll have some students coming in and talk about quantum, and then we will invite each of you for your opening remarks, and then we'll have Q&A with audience. Over to you, sir.
Thank you. So now our young quantum scientists are ready with their thoughts. So Dimple will give some introduction, and then we will ask them to come here. One person is going to speak individually one, and then we have the group presentation.
So we are happy to hear and see that there are some students of different schools who are eager to share their views on the topic related to quantum. So for the start of this, I would like to call Wasim Raza on the stage for sharing his views on the topic, importance of learning quantum mechanics in school. Over to you.
The universe is not only stranger than we imagine, it is stranger than we can ever imagine. On this momentous occasion of World Quantum Day, I, Wasim Raza, from grade 12th, representing Maxford School, Dwarka, New Delhi, would like to first off thanks Professor mmpant sir, EduTV, and our head of school, Ms. Deepika Sharma ma'am, for giving me this opportunity. And I feel honored to speak on a topic that resonates deeply with the spirit of today's celebration. I'm here to speak on the significance of learning quantum mechanics in school. As we have been graciously introduced to the transformative power of quantum mechanics and its profound impact on our understanding of the universe by our senior speakers today, it is essential that we equip ourselves with the knowledge and skills needed to navigate the complexities of quantum technologies. At its core, quantum physics delves into the mysterious realm of the smallest particles that make up our universe. Unlike classical physics that describes the behavior of macroscopic objects, quantum physics governs the behavior of subatomic particles such as electrons and photons. It suggests theories in a realm where classical physics may fail to prove itself. But then again, why is learning quantum mechanics in school so important? The answer lies in its far-reaching implications for the future of science, technology, and society. From quantum computing and cryptography to quantum communication and sensing, the applications of quantum mechanics are vast and diverse. By introducing students to these concepts at an early age, we empower them to become pioneers in these groundbreaking fields, driving innovation and progress for generations to come. Secondly, quantum mechanics fosters critical thinking skills that are invaluable in today's rapidly changing world. Quantum theory challenges a conventional understanding of the universe, pushing us to question the very nature of reality. By grappling with concepts as otherworldly as the wave particle duality or quantum superposition for us, students develop the ability to think abstractly and analytically, honing their problem solving skills in the process. Moreover, learning quantum mechanics cultivates quite a few other flares too. By grappling with the counterintuitive nature of natural phenomena, students learn to approach problems with an open mind and a willingness to challenge conventional wisdom. This spirit of inquiry and exploration lays the groundwork for future discoveries and breakthroughs, inspiring a new generation of scientists, engineers, and innovators. As we celebrate World Quantum Day today, let us reaffirm our commitment to providing students with tools and resources they need to thrive in today's age. By integrating quantum mechanics into the school curriculum, we not only prepare ourselves for the challenges of tomorrow, but also instill in ourselves a sense of wonder and curiosity about the mysteries of the universe. In conclusion, learning quantum mechanics in school is not just about acquiring knowledge, it's about fostering a mindset of curiosity, creativity, and innovation that will shape the future of humanity. As our conventional electronics and computer technologies start to transition from mechanical to quantum due to both smaller transistor sizes and quantum computing, let us embrace the importance of quantum education and inspire the next generation to reach for the quarks. Thank you.
Thank you so much. Now we have some students of KIIT World School sharing their views on the significant topic, history of quantum mechanism.
Thank you for having us. So, good morning to the August gathering. A very happy quantum day to everyone. I am Devang Vek from KIIT World School, Zone H4, Pitampura. Now, before I begin the presentation, I would like to thank our principal, Dr. Sangeeta Bhatia, along with Professor mmpant and EduTV for giving us this opportunity. So, since the morning, we have been discussing about the future of quantum mechanics. But before we delve into this microscopic universe, I guess we need to have a little insight on what was the reason and what were the circumstances that led to the creation of this new field of science. So let's have Yashas, one of my friends, to apprise you with the same, to apprise you with the macroscopic history of this microscopic world.
Devang, thank you for having me here. So, Thomas Young, an English polymath, whose famous double-slit experiment in the early 19th century provided compelling evidences for wave nature of light. His experiment demonstrated lights for the wave nature of light, inference patterns which were observed when passed through two narrow slits. Similarly, in the year 1900, Max Planck proposed his revolutionary theory of quantum mechanics, which challenged the classical understanding of physics by postulating that energy is absorbed or emitted in discrete packets, or more specifically, quanta. Planck provided a framework that further explained the puzzling phenomena like black body radiation and also paved the way for the quantum revolution that would follow. Niels Bohr, in the early 20th centuries, brought a further clarity to the nature of light. Building upon Max Planck's theory of quantum mechanics, he proposed his model of an atom in which the electrons would orbit around a nucleus in discrete energy levels. This model not only explained spectral lines observed in atomic emissions, but also provided compelling evidences for wave-like behavior of electrons, further blurring the lines between wave nature and particle nature of a light. So now I will like to hand over the mic to my friend Aditya for explaining more about it.
Thank you, Yashas.
So physicists were unhappy because there was no mathematical formulation of atomic model. So Schrödinger came up with his mathematical equation that changed the face of quantum theory. Let's understand the Schrödinger cat theory first before going to his equation. Let's suppose a cat is put in a box with a radioactive substance, a bottle of poison, and a hammer. In the instance of decay of the radioactive substance, the hammer drops on the poison bottle, killing the cat, which otherwise survive. However, unless an observer looks inside to confirm, the cat is considered both dead and alive. That's what the Schrödinger equation discusses. An electron is a wave, and wave can evolve randomly in space and time. Schrödinger equation discusses finding the probability of electrons to be present at a certain position at specific time, as it says that over time the total energy remains same. What differs with time is position of electrons in a 3D space. Now discussing about Copenhagen interpretation of quantum mechanics. It is the name given to a set of theories formulated by Niels Bohr, Werner Heisenberg, and several other physicists who spent time at the University of Copenhagen in their attempt to answer the questions raised by quantum mechanics. We have two cases briefing Copenhagen interpretations. First one, when the system is left unobserved, where in the second case, someone is observing the system. In case one, when no one is observing, the system is described by a wave function which follows the Schrödinger equation, whereas in the counterpart, when someone is observing, wave function collapses to a particular value and the probability of finding electrons is wave function square, which is psi square, as you can see in the graph. Thank you. Now I would like to invite Tanmay Bhatia.
Thank you, Aditya. So, how beautifully it is observed that there were revolutionary theories by different scientists with time. That's what Sir Niels Bohr along with Sir Werner Heisenberg mentioned in his Copenhagen interpretation, that existence of particle is unknown with all probabilities and all the events having some certain and probable events that cannot be determined by us. Then that was not the end. Three famous scientists, Sir Albert Einstein along with two of his colleagues, Sir Boris Podolsky and Sir Nathan Rosen, collectively known as EPR, came with a research paper which collectively mentioned that existence of particle is not only unknown as told by Copenhagen, but it is also unknowable until we measure it. Because Albert Einstein famously mentioned a statement that God is not playing a dice or he does not play a dice. So for example, if we have an atom which emits two photon, if one have 50% probability of us having a spin positive, then we don't say that another has 100% probability of having spin negative, but we clearly mention another also has 50% chances of having both spin positive or spin negative. This research paper was termed as EPR paradox by EPR, and they also mentioned that states were predetermined from their creation, like we cannot determine it, and they are hidden locally in two particles and they are still unknowable, which was also known as local hidden variables. And to prove this, later in 1964, after 29 years of EPR paradox, an Irish physicist, Sir John Stuart Bell, came with his inequality. This inequality was a mathematical expression which certainly expressed that particles do not behave linearly and had a variable nature. This Sir John Bell's theory, telling that particles do not behave linearly, was also considered as right for a long time, until it was observed that for this having this, if two particles are anywhere in the universe, they may have they may have their speed greater than the speed of light, for certainly behaving like variables rather than locality. So technically this is not possible, moving faster than speed of light. After this, Bell's equation was also violated, which was later proved by Sir Friedman and Sir Clauser in their experimental which they proved about Bell's inequality, which was also later proved wrong. And still we have some unsolved mysteries related to quantum physics and quantum mechanics about the entanglement. What do I personally want to say is, like, I do not think there is any communication between the two photons or two particles which we have anywhere in space, since all of us know that they are a part of a single wave function or a wave. If they are part of a wave, entanglement cannot be faster than speed of light. So if they are since part of one wave, if one collapses and one state is determined, we can easily determine another's. Or the second theory I want to personally, my opinion is, I do not consider light as the fastest. So maybe there is scientist between us or in a country or our planet, which will prove in the future that light is not the fastest, or what do he got there his ideas on entanglement, or his or her ideas on entanglement. That's what I got to say. And most famously said by Sir Niels Bohr, everything we call real cannot be regarded as real because it is made up of things that are not real. That's what I have got. Thank you.
Start first with Gurpreet ma'am and give us a sense of what's the opportunity like, because I know your firm operates at a global level, especially in the tech space. So how do you see the future of quantum computing from a demand perspective in the market? And then we'll go on to higher ed and school education and see how do we prepare the workforce for that.
Who is coming first? Depends on
You can present, if you want, but 5 minutes.
I think since I think in the interest of time, I had a very short presentation, but I will, go through it very quickly now because the time has been skimmed. My basic point of view that I want to present today is very simple. We have been hearing a lot since the morning how bit has now, converted into a qubit. Is movement can happen not only linearly, but it can happen anywhere in space. With that context in mind, I want to highlight 3 perspectives. What should be the educator's role? What should be the policymaker's role? And what should be the, of course, the employer's role, as Karthik told me to highlight, right? So educator's role from my quick understanding, and I want to play a small game here quickly. I'm going to show you a picture, and I want you to memorize that picture, okay? And I will just keep that picture up for 5 seconds, if that's okay with everyone. So here you go. Can you tell me what was 5 in that picture? मैंने तो count किया था 5. You have skimmed down my time. So I also have to skim down the time. Anybody? Anybody? Can you remember? Yes? Like this something. Okay. Now I'll tell you the reason behind it, why I said I will show it to you only for 5 seconds. You can see it as many times as you want. But what I wanted to highlight is, if I give you this picture, even for maybe 20 seconds, you will not be able to remember, until and unless I give you the framework behind it. So if you see, the framework behind it is, just try to imagine 1, 2, 3, 4, 5, 6 in a rectangle. Yes? So 1 is this, 1 is this, 2 is this, 3 is this, and so on and so forth. Because this has been converted into a PDF, so you can't see the framework behind it, but that's how it is. Now if I tell me anything, you will be able to recognize it. So the point that I'm trying to make is that each student is different, each teacher is different, but we need to use differentiated learning to understand the perspectives and how our students are learning. And with that, I think the teacher's role is 5-fold. 1, she has to integrate STEM education. She has to make sure that the learning is collaborative. She has to have hands-on projects for her students to experience that learning. And these are all things that NEP talks about, right? So I want teachers to make students explore, question, and innovate. Let's go a little back in our time. We had Gurukul system where all of this was in place. But somewhere down the line, we've forgotten that. So let's bring it back to our system. We are the leaders. We have always been the leaders in education. Let's prove it once again. right? With that, I move on to the employer's perspective. Now, according to the employer's perspective, you very rightly said, we see what is in demand in the market. So I think employers should be nurturing their talent rather than telling them you are not of use because you have now been outgrown and I want to hire somebody fresh and I want to replace you. Instead of that, if I think that my workforce should be ready for the future, then I should take the responsibility for upskilling them. And that's, for me, the most important thing as an employer. I want to nurture my talent, right? I want to make sure that my workforce is working as a contagious innovator. When I say contagious innovator, I mean whatever they do, their enthusiasm should run, in multi-folds to the person sitting to the right, left corner of the system. It should be so contagious that enthusiasm with which I work should be so contagious that it's like flowing through the entire room. That's what, for me, is a contagious innovator. And third, I want them to be ecosystem enthusiasts. They should be knowing what is happening around them, and they should be working towards upskilling themselves, keeping themselves abreast with everything that is happening around them, right? So that's, for me, the most important thing as an employer. And that brings me to the third perspective, which is what should be the policymakers' contribution. And I think policymakers have the most difficult part of it all, because they have to make sense out of nothing and everything, right? So I think that's why that picture there is very, very apt for me. And we have been talking about quantum, but I just want to bring into perspective the quantum effort worldwide. And in that, if you see India, we have set aside 60 billion rupees. And we are not far from the leaders, world leaders, and majority of the people. So we are putting our right foot forward, but where do we learn from? We should be learning from European Quantum Flagship Initiative, which started in 2018. We are now in 2024. Similarly, the US National Quantum Initiative started in 2018. We are in 2024 right now. We heard about one of my young friends talk about the National Indian Mission as well, but we are in 2024 now, right? Let's put our foot forward and see a few case studies that we can learn from. Again, this is a PDF, so I apologize for that. But the three main things that I wanted to highlight is the IBM case study, and of course, the Quantum Technology Initiative by Finland. So these are few case studies that we should be mindful of, and we should be learning from, and putting our best foot forwards. So what is the action plan according to me? This is the ready roadmap for you. You just need to plan your educational foundation well, put a lot of money into research and development, take part in workshops like this, thanks to Professor Pant. We are all here on a Sunday afternoon, enjoying and learning a lot about your quantum readiness, right? So participate in workshops, have a lot of collaboration platforms where you can share your thoughts, make partnerships alive, network a lot with like-minded people, collaborate with tech giants who already have the funds to do the needful. Do not shy away from collaborating with them. Have some pilot projects, fail fast, learn faster, and re-innovate the wheel, fastest. That's the roadmap that we have to follow. And last but not the least, be the talent nurturer and not the one to say goodbye to anyone. That's all from me. If there are any questions.
Quick question I have,
Yes.
Gurpreet ma'am. Your company has 700 odd tech people. How many of them are quantum engineers?
Frankly speaking, I think I am one of them who's standing right in front of you.
You are the
and
ecosystem
talking-
enthusiast, as per your slide.
Yes, exactly. And I am nurturing my talent. So the very fact that you said I've changed parties, no, I have not changed parties. The only step that I've taken is now I'm not nurturing young, bright students. I'm nurturing the people who are required in this change. They are the ones who are the most difficult to change. So I have taken that step forward, and I have taken that initiative for myself that if nobody will move, let me move towards that. So yes, to answer your question, at least 15 of them are quantum ready.
And how many job openings you have?
How many?
Job openings for quantum?
Not at all.
Not at all.
None.
But
None.
do you see on the
They
horizon?
are only in AI and Gen AI. My entire workforce is Gen AI ready. My entire workforce is Gen AI ready, and I'm proud to say that. Right? But if you talk about quantum, exactly, it will. Yes, it will.
Agree that there are no jobs.
Right now, there are no. Yes. Absolutely. Not for my company, but of course, there will be companies who must be having. For example, Google. I mentioned IBM. If they are upskilling their teams, then obviously there are jobs, that's why they are upskilling. And that's why they're investing. Right? It's just a matter of mindset.
Thank you. Thank you.
Thank you
Would
so
be
much.
Next, I would like to request Mr. Rahul Agarwal to talk about, given what you have seen from a demand perspective coming in, and even for the job she mentioned, like big companies like Google, IBM, Atom, they have job openings, but how do you see, is the university system ready right now? Like we don't have any BTech, right? In masters, there is some specialization in quantum right now. Certain institutions like IIT and NIT have a 1-2 credit course in quantum in BTech CS. But do you see the preparedness for university? Sure.
Good afternoon. So I'm going to take you through a small set of slides which talk about quantum readiness at the university stage. So if we look back, I'll take my own example. So I joined engineering course in computer science in mid-80s. And that was the time when there was a lot of uncertainty about computers, because that's the time the computers were being introduced in India. And so there was very little awareness what will happen when we are going to pass through this course. So the most in-demand jobs branches were civil, mechanical, or electrical. The growth potential was hazy. Career prospects were unclear. You don't know what will happen after I complete my course. There were very few colleges who were offering this as a branch. And some of my fellow students, they even switched a branch after first year. So, because they were unclear what will happen. But over time, you know, my decision has proved to be so right. So, if I look back, I see the quantum technology is in a similar situation as of today. And similar situation, as I think you were mentioning, AI was about 10 years back. So if I look back at 10 years back, there were very few colleges or very few institutes who were offering that kind of courses. But today, it is in so much of demand. So situation is that we have seen first quantum era, where the quantum principles were established, and there were a lot of technologies which were developed based on those. And we have seen technologies like laser systems, semiconductor devices. So all the phones, mobile phones, and computers which we use, all these are based upon the principles of quantum mechanics. MRI systems, Pansar mentioned, solar energy, digital camera, nuclear power. These are all the technologies which we have been using without being probably aware that these are based upon the principles of quantum mechanics. But now what we are going to talk about is, that is quantum 2.0, which is basically the second revolution. And we are talking about this because the quantum mechanics research has progressed to such a level that scientists can now even able to detect a single quantum and even can manipulate the states of that. And that is basically leading to evolution of some new technologies which are going to use the properties of your superposition and entanglement. And that's basically going to lead us into 4 different areas: quantum communications, quantum sensors, quantum computing, and quantum materials. So these are 4 broad categories. And here we have different applications which are going to be possible through quantum computing, which is artificial intelligence, drug design and development, cyber security, financial modeling, weather forecasting, logistics optimization, and computational chemistry. So these are various areas in which quantum computing is going to help us. And if we look at, there is a frenetic race which is happening across all sectors. So if you look at computers, so there are so many companies who are working in development of quantum computers and the quantum technologies. If you look at automobile sector, all these companies like Daimler, Tesla, Volkswagen, Ford, all these are working on developing quantum technologies and use it in their technology. In finance, again, there are a number of companies who are working in this field. Then ExxonMobil and Mitsubishi Chemical, they are working in the quantum chemistry. Then aerospace, Boeing and Airbus, all these are focusing on. So maybe I think you must be getting some answers. Pharmaceuticals, the companies are focusing on how they can use quantum computing and other technologies for discovering new drugs. So it is clear that the future is poised to be quantum, and it's important for us to know what is happening in India. So in the morning we talked about National Quantum Mission, which is focusing on 3 broad areas. First, the first one is to promote R&D and innovation in quantum technology, basically supporting startups and any organization who is going to focus in development of quantum technology. Then develop a bit-size computer. So we talked in the morning that TFIR is working on development of a 7-qubit computer. So National Quantum Mission is going to support that. And it is also looking to forward development of QKD, which is quantum key distribution, which is going to help in quantum computer safe encryptions. And also the third area is develop new products and services, world-class startups, and international collaborations. So these are 3 broad areas which National Quantum Mission is going to focus on, and government has earmarked 6,000 crores for this mission. So it's a substantial amount which government is planning to put to development of quantum technology. So it's a huge opportunity which can be there. There are various government agencies who have already started working on this, like DRDO, ISRO, CDAC, Department of Atomic Energy, CDOT, and NPL. So all these government organizations have already started projects in the quantum technology. There are various academic and research institutes who have started their academic and research programs in the quantum technologies. Then in private sector also, there are various companies who have started ramping up their resources in the quantum field to support the future quantum products and quantum services related requirements. So all this is based upon a report by NASSCOM, which has been published about 2 years back, and you can access it online. There are various startups which have come up in India, almost about 20 plus startups, which are working in different areas of quantum technology. So there's a lot of action which is happening in India as well. And NESCOM report, which I was mentioning, that is highlighting what kind of, there is a manpower challenge. So situation is there is a huge gap in demand and supply of homegrown human capital in the quantum field. And on-ground challenges are, there is intense competition to hire PhD scholars. They are looking to hire PhD scholars, but they are busy in their own research and they have academic commitments. Startups are not able to hire as skilled workforce is looking to work out of India. And there are some specific areas in which niche skills are not available. At the same time, this report highlights that in next 5 to 10 years, we'll be having quantum-based applications which are going to be available to all of us. And at that time, the demand for quantum skills is going to shoot up. So there's a huge opportunity which can be there if we start preparing ourselves now. So how do we get ready for this? Obviously, we'll look for our institute as a student, but probably we need not wait for that. Let's understand what are the skills we need to develop. So one is having basic maths and physics. Other is understanding of quantum concepts and quantum algorithms. Quantum computing is very different from our classical computing. So we need to kind of understand how quantum computing works and how the quantum algorithms are. Then there are various programming languages which are specifically designed for quantum computing, and there are frameworks available, so one can look for developing skills in those. And quantum computers and platforms. Of course, quantum computers are very scarce right now, and those are not very stable also, but those are being provided access through cloud. So cloud access is being provided for the quantum computers, and if you are looking forward, you can possibly run your programs also on those. So these are different quantum development environments. You can learn quantum programming, develop and execute code on simulated or real environment. So Qiskit is a very, very popular environment. It's an open source tool which is available, and if one wants, you can look forward to start working on this. Microsoft is providing something called QDK, Quantum Development Kit, and QP is being provided by Google Playground. And there are online platforms and resources. So IBM Quantum Experience, Cirque is from Google, QHash or Azure Quantum is from Microsoft. Then Xanadu is providing strawberry fields. Amazon Bracket is of course from Amazon, and Rigetti Forest. These are just some of the environments which are available on cloud, and you can access them. Then India has also developed a quantum simulator tool. So QSIM is the one, and it is developed by CDAC, IIT Roorkee, and ISC, and it is funded by Ministry of Electronics and Information Technology. So this tool is available free of cost, and you can use it online. So it is providing you the complete environment to write your code in Python, and you can run it on a simulated quantum platform. There are various online tutorials, videos available. You can have certain books. So I'm not going to talk about all these books. ChatGPT is another very good tool. You can look at exploring some concept, and when in doubt, you can probably ask ChatGPT, and it can help you, and it will give you some ideas further to further exploration. So I am just showing you some sample. I'll put these in the session handouts you can have. And there are formal courses also available. MTech courses provided by various IITs and also by some institutes. This again going to be available in the session handouts. Then at the graduate level, if somebody is looking forward to join engineering, engineering physics is a course which is having a lot of coverage for quantum mechanics. So probably if somebody is interested, they can look forward joining. And IIT Bombay and IIT Madras, they are also providing a interdisciplinary dual degree program for their graduate students. But it's not limited to IITs. There are other open courses also, and those are also being provided by IITs like IIT Madras, IIT Delhi, IICR Pune. QPI is basically in association with ISC Bangalore and also by MIT. And they are also available on SWAYAM portal. So these are different avenues which are available to you, and these are open programs. So it's not like you have to be IIT student only, then you can join these. Then also there are self-paced courses available on the online platforms like EDX, Udemy, Tech, and also QKrishi. QKrishi is offering a free course on Qiskit. And also Professor Pant is also offering a digital Gurukul, and you can have a program offering from that. So he is having 4 weeks program, demystifying quantum, quantum revolution, first quantum revolution, second quantum revolution, and mathematics of quantum. So these are the 4 courses which are available from Sir's Gurukul. It's available on this mmpant.com. So we need not wait, and let's just start the journey. That's what I would say.
Thank you so much, sir. Sir, a quick question. So in AI, what happened was that in master's level and above, there was content on AI and programs on AI. Then schools suddenly came up with curriculum on AI and it was a subject. Then at graduate level, institutes were looking here and there and they had to juggle up and come up with a BTech program at around AI. So do you think for quantum there is a readiness at graduate level?
Yeah, so maybe just few slides.
You had a dual degree program on IIT Bombay.
Yes, so one is, what is lacking is awareness about quantum computing. At the college level, institutes level, students are not aware about quantum, what are the possibilities. And the other is that the content, as you were mentioning, the content is generally focused towards quantum mechanics in terms of equations and mathematics and so on. So everybody feels threatened. It's so difficult, it's such a difficult subject, and whether I can really get into this or not. But there's nothing, see, it's basically a question of how the subject is being taught, rather than the subject itself being complex. So the same concept, if can be taught in a kind of a simplified manner, probably it could be, it could help. Yes. So you would like to say something now?
First, unlike today's educators, the quantum physicists always scared the world about quantum. What are the sentences? If anybody thinks he knows computer, he is mistaken. Feynman said, if you think you know quantum, you are mistaken. Somebody said it's weirder than the weirdest thing that you can think of. So firstly, it is that way. But what I want to do is I want to leapfrog to today's model. So instead of copying UGC, AICT, BTech, MTech, you forget that. And I'm encouraging all of you to explore it because I've seen that. There's a very well-known educational technology professor called Mike Sharples. Mike Sharples is a UK OU, very well-known. He recently had a book called Digital Pedagogy. UK OU has been for 10 years compiling what are the best pedagogies. And Mike Sharples has a lecture saying the new science of learning. What was he must be quite aged, retired, etc. And I think our Ramesh Sharma knows him personally also. In his latest presentation, you know the example he is giving. I asked ChatGPT to teach me quantum computing and then asked it to assess how much I have learned and so on. So that's the new way of learning. You're not going to wait for somebody who's qualified, BTech, AICT approved, etc. But you will go straight on to the new methods of learning yourself. Plus ChatGPT, if Mike Sharple says he learned it from, he did that experiment. And you can learn and you can assess also how much you really know. Because it allows you to make question papers, etc. And to me, it is the AI tutoring system, Khan Migo and so on, This will adopt to let you become quantum from zero, step by step, what you need to wave particle duality, uncertainty, superposition, spin, this, that, right up to quantum entanglement, which this children talked about. And you will do. So today you don't have to depend upon a university. In fact, I will now share with you the reason I organized this event was that I saw that in the last 2 years, this quantum is just within 10 people. And I was part of them. It is TIFR, it is IIT Roorkee, it is IIT Kanpur, it is IIC Bangalore, etc. Now, they're not really good. To me, they're still worried about 15-bit quantum computer, 20-bit. As you said, you use Qiskit and start making whatever you want. You don't have to wait.
Right.
That was the traditional thing. Today, it is already, and IBM already says, we'll give you so much minutes free. If you do something useful, we'll give you more and more time.
Right, right.
And the thing is about quantum algorithms, also to, as somebody said earlier, how to formulate a program, a problem for a quantum computer. This is what you first do in computing. You do this in school maths also. There's a real world problem, you put it in school maths level, then you solve that. So to me, the nation is on a complete distracted road towards this. And if you people have patience, video dikhayega zara sa. It's just, the reason I have done this, very honestly, and got all these school children, got all these people, is the government way of doing it is a sure shot failure way. They have no intention or no understanding of how things are, even the goal.
Hello and welcome to The Print.
Now,
I'm Mona Basu,
please
assistant
watch
editor
this
at The Print.
carefully
And today we
at 3
are going
minutes.
to talk about
And
the
we'll stop at
quantum
3
mission
minutes.
that was announced by the cabinet just yesterday, Wednesday this week. And what exactly this mission is, what it encompasses, and what we can expect from it in the future, that's what we are here to discuss today. And with me, I have Dr. Akhilesh Gupta, and he is the Senior Advisor at the Department of Science and Technology.
of zeros and ones. That is bits. This is a mistaken belief. The only thing is we do not have any physical device which can have 3 stable states or 4 stable states. At one time, there was a lot of papers in ternary logic where we have 3 states. Then your system will become smaller. It is only accidental that we have a system where only 2 stable states are available. हाँ, वो मैं ये जो बुलियन अलजबरा है जो लोग पढ़ते हैं नहीं ऐसा नहीं
सुपरपोजिशन हो जाता है ना तो दैट भी 1 0 गाइड भी हो सकता है
नहीं मैं ये कहना चाहता हूँ जो लोग बुलियन अलजबरा कहते हैं कि 0 1s के लिए बुलियन अलजबरा इज मच ब्रॉडर दैन 0 एंड
Professor Sunil.
So I just wanted to share my own experience. I was mentioning that I joined the engineering course in mid-80s, and at the time of joining that course, I also had a lot of doubt whether I will be able to learn computers or not.
आपने कहा 80 में बहुत कंप्यूटर आ गए थे 64 में पहला कंप्यूटर आया
I'm just telling when I joined. So I was feeling very, very scared whether कि मैं कंप्यूटर सीख पाऊंगा कि नहीं सीख पाऊंगा. So whenever there is a new thing, this happens. So there's nothing to feel scared, and if you join, you will definitely be able to learn.
I request Professor Sunil to give his opening remarks in 2 minutes.
2 minutes. 5 to 2. From me, it will be 30 seconds. You come, go and thank you.
Thank you so much, sir. In fact, after such conversation, it is very difficult for anyone to stand and speak. And especially when mentors like Professor mmpant sir and stalwarts like Ratan Datta sir. Sir, हाँ sir, मैं वहीं आ रहा था sir. Dr. Ratan Datta sir, to whom I have been listening for decades, because he was president for Computer Society of India also, so we had lots of opportunity to interact with him. The best part of this event was those 5 students, those who were presenting about the quantum computing. And probably the thing what you all have presented, dare to present here at this forum, where people, those who are sitting here, responsible for organizing this event, probably they are seeding for that future tree where India as a nation will work and feel proud. You covered all those things which I had prepared. So I don't know what to speak now. But anyway, wonderfully articulated. And starting from 1901, when this Planck's constant, which is basically considered to be the basis for today's conceptualized quantum computers. So starting from 1901, and then by, of course, Max Planck's, and then subsequently the work which was taken up further by Niels Bohr or Heisenberg and other, and all those got Nobel Prizes, in spite of having some criticism one over other. And then, after around 1927, there was that progress in the field of quantum computers was slowed down like anything, till 1970 when quantum information theory was propounded. And then, of course, when Feynman, who proposed the quantum computers model, quantum computer system, till 1981, when Benioff who actually started talking about quantum computers and how a quantum computer will work, and subsequently followed by 1994, which was a benchmark in the study of quantum computers when Shor and Grover propounded their algorithm, and those algorithms gave the confidence that these quantum computers have that potential to solve complex problems which otherwise these classical computers may find it difficult, if not difficult, at least time-consuming. Like a small example, drug discovery is considered to be one of the challenging area. The Google AI-driven application, it created 170,000 structures, protein structures, which were to be evaluated. And when people were trying to simulate it on a classical computer, it was the scientists, the researchers which were involved in that team, they suggested that it will take around few weeks or even a few months to study the protein interaction of 170,000 structures. If more than 120 most powerful computers of today, they are engaged into that process. Now this is for 170,000. Whereas the membrane protein, if you try to study, it goes beyond multiple times. Now with the classical computers, though when we talk about classical computer and quantum computer, we should keep these two things separate, at least as of now. Because these quantum computers, as of now, are not considered to be a replacement for the classical computers, because classical computers have different vertical of applications, and most of the problems what we are having today, they are able to solve it. But there are a number of problems why it is happening. If you look back for 60 years, 70 years, the development of information technology and the computer system, what we see, 70 years back in 60s, we used to have 4 major regions of computers, components: data, how that data can be processed, the application part, how those processed data could be transmitted at desired location, the network, and to making those transmission of data, transmission of information rather, safer and secure. After 70 years, our struggle is on those 4 parameters only. From flat file in 1960s, where text data could be stored, now type of data, what can be stored, image, motion, video, all those things have changed. The volume of data has changed. Now a Boeing aircraft which flies for 1 hour, it generates around 20 terabyte data and captures around 300,000 parameters. I mean 3 lakhs parameters value it captures, and the total amount of data which it creates in an hour is about 20 terabyte. Now with this voluminous data, before 85 or early 90s, the relevance of historical data was not that much. People started realizing only when concept of data mining, that AI, machine learning, started picking up, and people started thinking that if we have a data stored, we can still find some noise pattern from here to take futuristic decisions. So prediction would be done. Now, the volume of data from that text file is leading towards a kind of environment where we don't have data storage capacity, and that's how we are now either integrating storage devices, creating storage networks, piling up the data, and then developing applications which can process it. Now from that particular data, which is humongous, if we start processing it and analyzing it, with the time passes, now data is growing in multifolds. Probably all classical computers may find it difficult to process it, analyze it, and respond on real-time systems. And that's where these quantum computing, because as sir was mentioning that principle of classical computer is working on bits. At any point of time, any that storage structure can have at most 1, either 0 or 1. Whereas qubit, through superposition, it has that capability to store 0 and 1 at the same time. In simple mathematics, it reduces the required storage capacity to the 50%, at least if you don't go into the details. Now this new kind of storage, which is yet to stabilize, is heading towards a scenario where this voluminous information would be able to be processed on real-time basis and respond accordingly so that the limitations of classical computers could be eliminated or could be solved up to some extent. So journey which has started in 1901, we are into 2024, and how we realize, people realize about a technology, about a product, that how important it is going to, number one, how private sector is responding to it. Because it then starts giving confidence. And second, once that private sector laid down the foundation and shows the path that this is the technology which is futuristic in nature, then probably government also start thinking that yes, if it is so important that industry is working like anything day and night, why should we not? So at least we should start functioning. And for students, those who would be graduating in next 3 to 5 years, the scenario as it speaks seems to be very, very bright. Because the private sector, if you look at it, in 2021, the private sector funding to the quantum computing domain was around $770 million, which was doubled in 2021, just in a year. Till 2013, we hardly had double-digit startups in the field of quantum computing. In 2023, it surpassed 300 plus. Means that private sector, that those industries are looking that the way quantum is picking up, it is going to resolve many issues, many complex problems which industry is having today. And realizing this government doesn't react on just these statements. They very closely observe this. National Quantum Mission in the morning that Karthik very nicely elaborated. Wonderful elaboration that NQ National Quantum Mission was. Apart from those 6,000 crore rupees which is to be spent in next 5 to 7 years, government has also a projection rather than plan to create a workforce of 25,000 plus individuals. Now, if government is working to create a resource of 25,000 plus in 3 to 5 years down the lane, from where this resource will come? The role of academic institutions are going to be very important. This was one thing. At the same time, Department of Science and Technology has taken an initiative to promote these quantum technology-related initiatives by building up small infrastructure at institution. They have kept around 80 crore or so rupees for creating this, for promoting and creating such kind of infrastructure in the schools. Now, if government is acting like that, the overall spending on quantum computing in 2023 was around $4.1 billion worldwide, which is expected to surpass $32 billion in 2032. The kind of funding, private funding, which is coming up into these quantum startups, now you see a plethora of organizations, what Rahul sir also shown in his presentation, that probably we are not aware of it. We are not aware of this dominating technology, dictating technology, which is ready to take up in near future. And probably the responsibility of academic institutions is more. Unfortunately, they are not ready to respond. And probably this is the reason why this conference is. And rightly, sir said, that there are many things which cannot, which may not, and probably which will not be taught in the classes. Because we know the process of syllabus formation, revision, we don't need to discuss about those things. If university system follows to revise the curriculum in 7 to 8 years down the lane, in 7-8 years, now technology is entirely changed. Things are changed. And if a student takes admission in first year and we are deciding the latest technology as on date, after 4 years when he passes out, the scenario gets changed. So it is very important for all of us, and that's what I feel privileged today to be part of this event. I've spoken at lots of forums. various forum industry and academia. But this was my dream platform. When I got the message from Professor Pansar, who has been our mentor for more than 2 decades now, he has been guiding, and our MCA fresh batch starts with his blessings every year for almost last 15 years. So this is something, this occasion is something which is very special to me. I have learned a lot of things today, and those things are so simple, presented so easily, that as a teacher, I'm going with lots of learning today. But as an institution, of course, we work on Sir's suggestion. He had suggested, and I wish to share this. The first quantum computing course which I went through was on WhatsApp. Can you imagine the course can be run on WhatsApp? And that course was delivered during COVID, July 2020, by Pansar for me and for all my faculty and students of postgraduate programs. So he's working, this conference may seem to be a new initiative, but his work started years back. From the classroom to the course on WhatsApp to the event which was organized at Gurgaon, and today a conference. We organize conferences, and trust me, at 5 p.m., 4 p.m. in the evening in any conference, hardly you find people attending those sessions. People are left with either those who are presenting the papers or those who are organizing the conference. But still, if these many students, if such people are sitting here, I think we are on right track. And let us take these learnings, take these discussions forward to make at our institutions our student aware, to make aware our faculty, because they are the first person to be taught. And let's try to prove this conference worthy in time to come. Thank you so much, sir.
Thank you, Professor Sunil. And now I think the stage is set for you, Dr. Bhavna. I think a lot of people have asked questions around readiness at school level. This is where it starts. So I think you are the right person to close the session with your remarks.
I believe it is thank you so much, everyone, for giving me this opportunity. Jai Hind, everyone. I'm Dr. Bhavna, and I believe this is, everyone is aware of quantum mechanics, quantum optics, quantum biology, quantum material science, quantum condensed metaphysics, quantum field theory and quantum gravity, quantum metrology, quantum sensing video, quantum text, quantum imagining, quantum machine learning, quantum thermodynamics, and quantum biotechnology. All these are fields which are currently we all are working and the researchers are working on. Yes, I am. And I still remember Sir told me that please read the article Usefulness of Useless Knowledge. That article was so nice. And I would like to just relate here because my fellow panelists have already spoken so many things. So I would like to, because I'm denoting here a K-12 segment and I'm a teacher first. And when a teacher is in the classroom, there must be some hands-on activity. So I would like to have few students here. Yes, 2 boys, please come here. See, we know, we have heard so many things. Yes, you both of you, please, boys, come. Come fast. We have heard since morning quantum, superposition, बहुत कुछ सुन लिया, बट क्या मेरे बच्चों अभी तक ये समझ में भी आया ये है क्या? I'm sorry, but this is the fact. है कि नहीं? चलिए, अब ये सिक्का उछालते हैं, जरा देखते हैं क्या आता है. Let's see क्या आता है. Let's see. We will assume, okay? So you just toss it, have it in your hand. And we'll see what you will have it. Okay. Any guess, sir? कितना डिप्लोमेटिक आंसर है. 50% है. हम एक भी बोल सकते हैं. Yeah. Very well. Okay. Let's see what it is. It tails. Okay. Let's toss it now. You do it. Wow. And sir, Rahul sir. क्या होगा?
I think it is head.
It's head. चलिए. It's tails. ठीक है. हाँ जी. Yes. So it is all about what? In the classical computing, we know about two states. जो हमारा, it's like normal. It's head or tail. But this randomness, this particular. Thank you, बेटा. Okay, just do me a favor. एक और करते हैं. इस coin को अगर हम roll करते हैं यहाँ, कर सकते हैं? One more experiment. Can you please help me? Okay. So what state it is? Until it is rolling and it is not dropping, what state it is? क्या है? What state it is? Please, once more. Once a coin is on the edges and rolling like this, there is nothing, neither a head or not a tail. Thank you so much, boys. Take your seat. So the activity demonstrated here, how randomness is used in classical computing and highlights the element of unpredictability. We can just relate it to the quantum computing and utilize the principles called superposition and entanglement. Since we are listening it, we know it. Now we know the superposition is what? When there is no state. Sir, I am right? गलत तो नहीं बोला? मेरा वीडियो भी बन रहा है, sir. Fine. Fine. To on a lighter mode. So when we talk about, I have a presentation too. Sir, can we, how we can open this? Thank you so much. Thank you so much. I have one more thing with you. Now, any one of you have heard song कोई मिल गया? सबने सुना है? Lyrics याद है? थोड़े थोड़े चलिए. अब हम क्वांटम फिजिक्स की बात कर रहे हैं. थोड़े थोड़े जितने याद है उतने बोल दीजिए.
कोई मिल गया, मेरा दिल गया, क्या बताऊं यारों.
No, not this one. Pick movie से. मैं इधर गया, मैं उधर गया. उसके बाद आता है. थोड़ा सा पैराग्राफ थोड़ा जल्दी.
बस उतने तक नहीं आता है भावना. इतने तक. अब तुमने बीच में रिदम तोड़ दिया.
अच्छा. कोई इधर बेसिकली सी सर रिदम टूट गया. इसको भी एक्चुअली क्या है, अब मेरे पास सिर्फ 30 सेकेंड्स है, उसमें से भी मैं एक एक्सपेरिमेंट कर चुकी हूँ. सो इन द पॉजिटिविटी ऑफ टाइम आई एम जस्ट शेयरिंग हेयर कि उस गाने में इधर गया उधर गया. इफ यू आस्क मी, I can relate it, that elements of wonder and discovery which resonate with the exploration of the unknown after associated with the quantum physics. इधर गया उधर गया, क्यों गया, इधर गया पीछे गया. So this is how a classroom teacher should teach. This is how a classroom teacher should relate. It is not a big term, it is not a big thing. It is just a simple phenomenon which has to be there in the classroom with the teachers, and the teachers can relate it very easily. The only thing which the teacher has to do is to prepare a proper lesson plan. Once you start, even I always quote this thing, that you are a teacher, You just wear a crown of artificial intelligence and your beauty will be personified. You will look like a Queen Elizabeth. Because once you have the knowledge of, if once you empower yourself with AI, you will definitely have this power. Because these kids, those who are sitting, I was just, I've just changed my presentation after listening everything and I'm being the last one. Sir was saying what I should say and then I was just thinking, what should I say? So I changed the complete presentation and I just want to add one thing. Cultivating quantum ready minds today for the challenges of tomorrow's world is the job of a leader now. And I'm thankful and I'm blessed that my sir, my Pant sir, he's always a guiding force behind me who has given me this opportunity to lead this thing, and we are taking it to the classroom so that my students should enable themselves for today, which I hope that, although that was a content, how I can have it in my curriculum, I can have it in my curriculum and it is very easy to integrate interdisciplinary, multidisciplinary approach. I just added art form into it with adding a song here, activity, hands-on activity. So here we can relate very well. And here, personal development training, which Gurpreet ma'am has rightly said, we need, even though for that reason only CBSE has made it mandatory that 50 hours training is must for the educators, because the learner who is listening to them, they have ample power to empower themselves on their own. That's what we have seen here right now. All the students, maybe their teacher even don't know about what is quantum computing, but they have today explained very well about that what it is. Am I right? So they are self-learners and they don't need any support. They just need guidance. They just need so the role of the teacher, as we always say, that the role of the teacher is now curator, and now right now academic integration, interdisciplinary approach, which I just shown you right now. And this is how creating quantum ready learning environment, which Rahul sir has already shared, that there are so many resources, so many people working on it. You just have to take a lead and you have to take that awareness to the next level, and you need to showcase that to your learners when you are in a classroom. Then comes to collaboration with industry and research institutions, engaging with the community. That's what we are doing right now. And we all have one interest in our which has taken us to this level, is that we all are the innovators. We want to take this society and we want to be a leader for the future. That's why we all are here. Am I right, sir? Yes. Because in 2040, when we talk about and we challenges, we all know there are so many challenges. When we talk about, when I see a class nursery child, my responsibility for a class nursery child is to take that child to 2040 when the child will be graduating, means completing class 12th. So when we are thinking about this, government is still thinking about formulating the rules of AI, implementation of AI, which is still not there. So maybe by 2030 we will be having that rules, and by 2040 we will be having the rules for quantum too. But my student who is right now in nursery, that's what new education policy and national curriculum framework, school education talk about, that you need to encourage curiosity and sustain that curiosity, and you have to focus and empower your learner with the scientific skills. This year is a STEM year. All the planning, everything from the CBSE guidelines are there to encourage the STEM-based learning among the learners. So this is what we have to do. On the page number 219 and 193, it is clearly mentioned, encourage curiosity. Encourage curiosity in the learner, and that is the national curriculum framework talking about. So I hope I am here for the call of action. I want all the learners to join me on this journey, and I definitely need support from all of you to please come and visit to my school so that we can encourage and create a generation which is ready for 2040, not for 2024 की क्लास पास हो गई, बच्चा तीसरी से चौथी में और चौथी से पांचवी में चला गया, ये अब हमारे लिए इम्पोर्टेंट नहीं रहा है. Thank you so much for listening me.
Sir, do we have time for Q&A or 5 minutes? So any questions from the audience? Yes, sir.
It started private funding only. Who will do? I cannot go to a venture capitalist. He will not fund it. Banks will not give the money.
Yes, sir.
They will give. No.
Sir, most of this funding is not from the banks. They are the angel investors who...
Angel investor will not give me unless I have something to show him.
Naturally, sir. Sir, those...
For that I have to do the bootstrapping.
No, sir. Sir, in fact, any startup doesn't start with a product only all the time. If, like what happens here only, TIE, after every quarter they hold a meeting here, and any student, anyone who has some idea, who has tried to work out on it, and just a draft, if he...
Okay, fine. How much money they will give me?
Pardon, sir?
How much initial money do you think I will get?
Sir, how much money he will get? Sir, it will be on the probability of scaling up it and reaching it, on those factors.
You see, that's what I'm trying to say. My initial budget, if I have to get good people, will be about 1 crore of rupees per month.
Sir, one of my student here only, last year he got around 2.5 crore in the first meeting.
That's
so,
wonderful.
so it depends on the concept, it depends on the noviceness of that idea and how it can be scaled up to address a particular problem.
Absolutely, absolutely. Thank you very much.
Sir, please.
So maybe the way to think of this, sir, is to say that in today's day and age, to develop great companies that are investor ready or angel investor ready, you don't need to be a coder or a developer. We are in a world of no code, low code development. So no code. And if you think about all the companies today, be it Microsoft, be it IBM, be it Amazons of the world, they are all moving towards this model. So if you look, if you think about Microsoft, they have came up with this, I'm sure all of you have heard of Microsoft Copilot, which is their LLM tool. But what they also have done is, and I'm saying from the perspective of generative AI, what they've also done is they've started Copilot Studio, and then they have also started Copilot Transformers. So you can just use those transformers and build your own LLM. So you don't need a programmer or a developer to get started.
Like APIs earlier people used to.
All you need is the ability to connect the dots, have those multiple threads of conversation. So I guess that whole notion that there is always that difficulty to start is probably an old paradigm now. Thank you.
Especially in the high-tech area. I know that the innovation doesn't breed in large organizations. It breeds in very young people with very fresh way of thinking, out of the box and trying to do things. I've had a 9-year-old get a patent, a 12-year-old girl getting a patent, a 9th class boy getting an award from the Prime Minister of India just last year. And these are innovations which I am very proud that I have just helped them a little bit to find the resources to get their idea to the next level. So it's just the requirement today is not just for money, but for people to really mentor these young minds who have very fresh ideas and they're very passionate about it. To find them is a big problem, but people like me have found a lot of them. So it's just a matter of giving them the right guidance which is what we have seen coming from Dr. Pant and others in the group. If we have this kind of conversation and we also engage with these entrepreneurs, I think we can really solve some of the most challenging problems. And the kind of ideas that these young people have is just phenomenal. I just can't really have the right words to be put in, but I have seen people go abroad with those ideas international and do wonders. Unfortunately, they don't get the right breeding ground in India, but there are those same people have come back to India and brought that technology back to India and are really making businesses around it. So it might take a longer period for us to really get there, but yes, there are a lot of innovative talent which is just waiting out there for guidance from people like us.
Just a small, I know late 80s, CSI won lot of awards in coding. Singapore, Philippines, and Malaysia. We took it to the President of India and showed that these are the children who won this. These were school children. But now you don't need coders. Coders are getting obsolete. That's where I think my friend said, you use Microsoft or Google something so that you can do it. That's why AI quantum computing come together. Okay, one other thing, I found Dr. Chipper has some program for the students, but I wrote to one VC that please add a course on AI because 8th and 12th class students have got AI. Then quantum computing and supercomputers are essential. You have no program for undergraduate level, that is BCA, BSc level. I have got no response. Whereas, you see, because I think the Vice Chancellor, I wrote especially about my own qualification, but he didn't worry about it. That's unfortunate, but I am pushing it so that it comes up. Thank you.
Thank you so much. We are completely out of time. I want to thank my panelists. I think this has been a very informative session for our audience because we had so much of diversity of perspective. Thank you so much. You can always catch up with them offline after the session. Thank you.
Thank you, Karthik ji, and thank you, friends, for this really engaging session. We are continuing with our last session. So I would like to request the chair, Ms. Minu Arora, and the panelists, Richa ji, Ritika ji, and Dr. Vandana. Oh, we are not going to play those videos. They lot of नहीं वो बहुत time खराब होता है उससे. I will read their CV. मेरे को कुछ करना है? अब तो घर जा रहे थे. वो मैम ने रोक लिया. नहीं निकल जाओ चुपचाप. उनको बोल देना सर ने मना कर दिया है. क्योंकि हर वीडियो
चलो एक बार मुझे पढ़ने दो.
दिख जाएगा. बड़ा करना है.
ये कौन सी है? ये क्या लिखा है? केरिया.
हाँ क्रिया.
Kriya University, with her academic background including a master's in education, master's in psychology, and a diploma in training and development. She brings expertise in education.
मैं इंट्रोड्यूस कर रहा हूँ. आप रिपीट करते रहो. प्रणव जी. Okay, friends, let's begin with our final session for this event. And here the session is about parental awareness for quantum readiness. I will request Dimple to introduce the chair for this session, Ms. Minu Arora.
Miss Meenu Arora holds the position of Associate Director of Outreach at Kriya University. With her academic background, including a Master's in Education, Master's in Psychology, and a Diploma in Training and Development, she brings expertise in educational counseling, career guidance, and parental support. Boasting over 25 years of experience in educational sector, she has interacted with students, parents, and teachers within schools and currently focuses on the realm of higher education. Meenu is a staunch advocate for the importance of liberal education, helping students and parents understand its value. As a certified counselor from NCERT, she is driven by a desire to assist students in making informed career choices and preparing for their futures. She leads workshops on various topics and an instrumental in developing for training programs for counselors. Her contributions to guidance, counseling, and life supporters empowerments have been recognized with an award from ASEAP. Thank you.
She speaks so well. I'll request her to go ahead and introduce Miss Richa, who is sitting to our left. Please go ahead. Yes.
Richa Malviya is a PhD scholar at NIEPA. She has been member of CBSE Committee for Development of Capacity Building Programmers, CBP, on educating parents about education. Proposed to be offered CBSE teachers as per the latest CBT guidelines that will equip teachers, individuals with the necessary skills and knowledge on active learning on 21st century workforce, which has been released by CBSE in November 2023. She has been working in areas of curriculum, syllabus and textbook development, evaluation, training, research and consultancy. She is a gold medalist in B.Ed and M.Ed program at Guru Gobind Singh University and MET University. AUUP, she has co-authored several books on education, psychology, technology, teacher education, science education, value education, and gender education for graduate students. She has the experience of teaching at the school level and college level. And since her appointment in Jagannath University 2018 and visiting Jagannath University faculty at JIMS Rohini. Presently, her research interest focuses on self-learning, enables self-learning and self-regulated learning in higher education institutions. Thank you.
Next speaker is Ms. Ritika. Her voice is better than mine.
Ritika Subhash is an educator and an ed tech supporter. She has spent over 11 years in bringing personalized maths learning programs to classrooms and students across socio-economic strata. She has worked extensively with schools in Asia, Middle East, and Europe, and has supported thousands of teachers and students in adopting blended teaching and student-driven learning. Ritika is also the founder of Parent Academy, an organization with a mission to bring conscious, harmonious parenting principles to 1 million families. In next 10 years, she is the creator of Art and Science of Peaceful Parenting course, the host of Parenting Truth and Dare podcast, and author of children's books. Ritika uses elements of storytelling and empathic coaching in helping parents see changes in their lives. She also conducts teacher training on variety of topics, including building a growth mindset, learning to learn, and lateral thinking skills. She was recently awarded the Rex Karma Veer Chakra 2023 for her contribution in the field of education.
The final panelist to our leftmost is Dr. Vandana Gulia.
Cyber safety learner and speaker. She specializes in cyber safety awareness, education for educational institutions, law enforcement agencies, enterprises, etc. Based in India and the UK, her company has been running various programs, trainings, and workshops to train people, organizations, and police officers to understand cyber threats. Her programs and trainings offer strong defense against cyber frauds and attacks. Dr. Gulia is also the founder of No More Missing, a national-wide initiative, which helped authorities in finding thousands of missing children and educated people about threats around youngsters. The campaign reached more than 42 countries and was also appreciated by former President of India, His Excellency Pranav Mukherjee.
Thank you, Dimple. Clapping is easier in Telugu. Now I request Meenuji to kindly proceed. Thank you.
So thank you so much for being here and not running for the tea. So I request you that we will try to finish it as soon as possible so that you can enjoy your tea, and I can understand all of you must be tired. So today we are, since morning I was listening to everyone and what is quantum mechanics, and she gave beautiful list of whatever quantum dash we learned during the day. Lot of terms we used. And now this particular session is going to be very different because we have talked from the industry point of view, we have talked about from the school point of view, and all others, but we cannot complete the loop if we don't take care of all the stakeholders. And parents are very, very important part of the entire cycle. वो पहले बोलते थे ना कि अगर किसी भी बच्चे को बड़ा करने के लिए जो पूरा village है that is required. So you cannot escape without talking about the parental awareness about the quantum world. So the next term, I don't know where is she, I think Bhavna was talking about that. So another term which we need to add to that is quantum parenting. So there are two things. One is parental awareness about the quantum world, and that parental awareness, I think, should be called as quantum parenting. We talk about responsible parenting, conscious parenting, but quantum parenting is a little different. And before I start and I invite the panelists here, I would like to share a few of my experiences. I remember when I started working with Professor Pant in '98. My child was 6 months old, and I was working with him on online education. And I used to sit there, I think, for 3 to 4 hours. And it was the dialing system, because it used to dial, and then I used to plan that how can we develop certain games or certain programs with the help of online education. And that time I was also working as a consultant, as a counseling psychologist with a company who was dealing with students. And during using those CDs, game CDs, I used to administer the play therapy with kids. 6 months old child, my Professor Pant told me that, Meenu, why don't you do online counseling? I said, sir, who has computers? Why online counseling? I'm a psychologist. That touch is required, that empathy, sensitivity, unconditional positive regard. Everything came to my mind and I ignored. I did not start online counseling. And here I am sitting here, chairing the session on parental awareness about the quantum world when my own child is 25 years old. So that is the journey. I think in this one experience, I have said it all. I did not have that vision. Being a career counselor, being a psychologist, and I missed the train. In fact, I will say I missed the train that time, but I caught it very soon because I understood what he's saying and understood fully 360 degree in the past 10, 15 years. So, and that time we were developing, softwares for career counseling. So, having said that, parents are so important. Because if I'm not aware as a parent that, online counseling is important or anything else is important, I can't guide my own child, forget about the world. So now here, when I'm sitting here, I will be sharing my experience as both, as a parent and as a psychologist. So yesterday we were having a session in India International Center. So all the class 12 students were there and they came along with their parents and, and one elder brother also came. So we were just having a discussion. So this elder brother said, ma'am, I would like to share something. He did his BTech and he was a very active member of MUN. And somehow he got so interested in MUN that after completing his BTech, he did not want to continue as an engineer, but he wanted to do international relations. So he walked up to his parent, he belongs to Kolkata, that I'm a little confused. I've already finished my BTech degree, but I'm more interested in IR. So first the father asks, what is IR? So, okay, international relation. So he just looks at his son, and that's exactly how he told me. He said, the father just looked at me and said, work hard. He said, work hard, but in what? In IR or BTech? Parental awareness. Parent did not know. Just saying work hard means what? Today, in today's world, it's not only work hard, you need to work hard very smartly. And that parent could not guide him. And he's working somewhere now, he did his international relation finally. But that doesn't solve the purpose. And many times I hear parents saying that, oh, today's kids are very smart. We learn a lot of things from them. And I'm one of them. I also say, oh, I learned a lot of things from my son. And if I'm able to say anything which he doesn't know, I have a sense of achievement. That I know something which he doesn't know. See, earlier, in initial times, parents used to be the Google. Children used to look up to the parents कि जो भी question पूछना है मम्मा पापा को तो आता ही है. My son also had the same view, by the way. So, I tried to be a very good mother and I tried to teach him social studies. So he tried once or twice, then he said, Mama, you leave it. I will manage. So now it has become, and I hear it from many parents. One particular parent, literally cried, and she's an IS officer. She said, Meenu, I feel so insulted at home because my son says, Aapko to kuch aata nahi hai. So because of that, she used to feel frustrated, and that spoiled the entire relationship between, the child and the mother. Anyway, then I had to tell her, don't worry, as a psychologist, I also hear this, कि आपको कुछ नहीं आता है. So that's okay, because at home, children are expecting a lot, but now they have the Google. First of all, they will not come to you to ask. They will just Google. So, and if they find the answer as it is, they don't need you. So, when the awareness is increasing so much, and here I hear so many parents saying that yesterday only, because these girls are joining Kriya University, so I was just, mothers were also there. So they were just telling me, I improvised on my vocabulary, that there are certain words which they use as a lingo. That giving it means something and saying this means something else. So I was also listening to it, and I was seeing that the mother was trying hard. And she was saying, oh, now I also know these words. She's smiling, so she can relate to what I'm saying. Am I right? Mothers also start, they also try to learn. So when we are trying to look smart, we are trying to feel smart, we are trying to look knowledgeable in front of our kids as far as these languages, dresses are concerned, then it's all the more very, very important that we need to be on the same platform when we are talking about the future. That means a parent should also know about the quantum world or whatever quantum mechanics, quantum biology, whatever terms we have used. Because otherwise, how will you, as a parent, how are they going to have a conversation? Where will be the dialogue? You cannot keep talking about working hard. You need to talk about, okay, how can you work smartly and survive in this quantum world? So as a parent, I need to understand. And today, like my learning was, like my son was talking about that he wants to do PhD in sustainability, and suddenly it struck me that quantum is related to everything. So today I'm going to go back and I'm going to have that sense of achievement that you should think about quantum sustainability or the role of quantum mechanics in sustainability. I don't know. I will have more discussion and I will come up with the right word. But it is everywhere. So having said that, now as a parent, we are dealing with all sets of age groups. So that is the reason I have 3 panelists here, and all 3 of them are going to talk about parenting or parental awareness for the quantum world for different age groups. Although I'm going to start with Richa Malviya, who is going to talk about the parental awareness for the preschoolers. But before Richa starts, I will just say that I personally feel, Professor Pant, that parental awareness should start with expected mothers. So, and I'm going to, I'm working on a program, by the way. I'm working on a program. I'm working with the hospital. Going to. Great. Because that's very, very important, because parenting doesn't start with the birth of the child. Parenting starts with the thought that I want to be a parent. And it's very, very important.
I have a whole article whose last line is, the womb is also a classroom.
Yes. So Chakravyuh in Mahabharata, I think, was not wrong. It happens.
No.
I have
It
a
is
lot of
today, in Australia, there is a lot of research on that. And children learn their mother's voice, various things, songs, etc. during that. Because the capacity, the cognitive capacity of that infant or fetus is developed during that time, after 3 months or so.
After 3 months, yes.
So my problem is I am knowing all about it, but how do I go to a lady and say, are you expecting?
No, I'm working on
That
that.
you can do.
I will get back to you. So Richa, over to you. You need the PPT?
Good evening, everyone. The topic of my presentation is parental awareness for quantum readiness. This is basically for preschoolers. So parents are actually the primary caregivers of the young child. So if we look at the report given by World Health Organization, to grow and develop the child, develop children optimally, they need to receive nurturing care. So these 5 interrelated and indivisible components of nurturing care are good health, adequate nutrition, safety, security, responsive caregiving, and opportunities for learning. So these are the major nurturing that every parent must know, just like father knows the best. Children will always need the nurturing of the parents and support, but they are not the blank slates that we assume coming into a physical lifetime. So the future of tomorrow, that is quantum children, we need to understand that they are advanced souls that are here to help all of our humanity move into a new reality. So as parents, we are operating in an unknown territory. We need to move into a new level of flexibility with all of our parenting. We need to understand that each of our child has talents and gifts and uniqueness that they wish to express. So love them fully with all your heart and celebrate their uniqueness. We also need to understand that quantum kids are providing us with the example of where we are moving towards. And we have a great opportunity to model them as we move through our own shifts. Also, children will always need us nurturing and support. So this is always going to be very important, but managing aspect of parenting needs to be diminished greatly. Our job as parent is to support the child to the highest potential and allow them to their path. So what would be extremely helpful to for all the children is parenting through the flow instead of structure. So this will only happen when you as a parent or a grandparent being willing to throw everything that you thought you knew out of the window at any given moment and take a complete new trajectory based on the given moment. Conditioning the limits. A lot has changed in the society and consciousness over the past years. So in past, many cultures had a belief that negative reinforcement was a way to raise strong and tough children. Even a grandparent used to say, spare the rod and spoil the child. Discipline was the name given if you were negative, then you will be, if you are positive, then you will be considered soft. So as a consequence, we had a drill sergeant fathers and dragon moms. So life was tough, and if you weren't tough enough, you wouldn't succeed. Parenting was based on the concept of survival for the fittest in many households. Everything was push, 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 because that was how we would survive in this dog-eat-dog world. So society has gotten better, but still remains a lot of conditioning. So let's move to positive psychology. I am a firm believer of positive psychology. There are some useful thoughts that have come up in this area. What psychologists have found is we perform better in every area when done in positive environment. So no shock to be there. People love positive encouragement and recognition. Yet most people in our society are conditioned to use these as a reward for achieving something, not as an engine that drives the performance. So you as a parent or grandparent have the added benefits of being able to express to the kids openly. For example, giving a pat on the back, a gentle smile, and don't underestimate the power of your voice. So what you say and how you say it can have effects that can last a lifetime. So these are different techniques that you can teach the small preschoolers. Like you don't have to teach physics to a 4-year-old. Simple science would work. Like drop a ball, toy or cup, whatever babies learn. This trick, dropping and having their parent pick up the toy over and over again, they try to make them understand that this is called as gravity. And this is the gravitational force. So slowly children also develop an understanding towards physics concepts. You can also roll a car or a similar toy with wheels across the floor and watch the deceleration, motion, and inertia. Like float a boat in your child's bath water and demonstrate buoyancy. Do experiments with magnets and demonstrate how food goes from hot to cold or cold to hot. So there are easy scientific experiences that you can give your preschoolers as a parent, like using a magnifying glass or a microscope attachment on your phone to explore the world of tiny. Visit a public observatory or a planetarium to see the universe. And please believe me that kids enjoy it. They really like it. Like use a bubble solution with a coat hanger in a square shape to explore the resonant membranes. Glow crystals at home. Like I also have 2 kids. The elder one is 4 years old and the younger one is 2 years old. So they like, I have brought a science experiment kit from the nearby market. And they really love playing, like making colors. Mama, see yellow plus red, I have mixed it and it has become orange color. So they are learning colors, they are mixing colors. So actually kids love doing science experiments. So never underestimate your kid, like he is younger and he cannot learn science at a younger age. So even 2 to 4 years old kids can also start doing science experiment. You can grow crystals at home, go to your local museum to see the work of archaeologists, anthropologists, botanists, and biologists. join the fields of the naturalist group, buy a simple robot kit from an electronics store or a science experiment kit for kids. So children benefit from parent-child relationship that is verbally rich and emotionally supportive. We need to understand that we have to forget the old structure of parenting. Instead, we need to go with the flow. That is very much important for today's parents. You need to set high standards for your child and see your children in their highest light. Also, please remember that the optimum ratio of positive expression to the negative expression must be 6:1 only. Focus on growth and learning. You create growth mindset within the child. Play with the practices of positive psychology. And also watch the dosage. Parent education. So there are different programs to teach parents to enhance the home environment in ways that benefit the children's learning to take various forms and may produce substantial outcomes. Some of the parent education programs are Prodigy education. For example, Prodigy math game, Prodigy math tutoring. In education.com, they are also teaching learning activities to the preschoolers, games, and they are giving small worksheets as well. Even Khan Academy are conducting such programs, Duolingo, NASA at Home, YouTube Kids, Google Arts and Culture, nationalgeographickids.com, Code Spark Academy. They all are supportive for parent education. So parent education also includes home visits by parent educators, group sessions led by previously trained parents, and workshops and courses taught by experts. Even there are also child development institutes that provides access to books and articles so that parents can read and understand how to talk to the children, how to behave with the children, so that we can also shape ourselves to teach the quantum kids. Family strengthening and parent skill training workshops, National Parenting Center is there, Parent Encouragement Program. It is an online parenting program to spread awareness regarding parental education. Even US Department of Education is working and giving access to direct resources for parental education. So there are different universities also, for example, Illinois Quantum Information for Science and Technology. It is working for parental education. Even the museums, you can make your children visit museums of science, and quantum physics for kids.com. So for parents of preschooler adapting to emerging quantum era, the core message is simple, very simple. Don't underestimate your students. Kids enjoy everything that is taught to them through fun. Thank you. And also here are some books, like I usually give to my children Quantum Computing for Babies, for younger kids. And Chris Ferry and Woolly have done a very good job in making simple concepts easy. Yeah, sure. So, yes. And there are different books by Chris Ferry, Quantum Physics for Babies, and Quantum Information also. And even David Havok have given the space book. So there are different books nowadays. You can start your kids' education from the basic level.
Thank you so much, Richa. That's really very, very informative. I have not seen these books. and I think, as she rightly said, from that Newtonian parenting, we have to move towards, again, quantum parenting, which is the holistic approach. Because, various researchers have also proven that neurologically speaking, the kind of environment the child gets, every cell gets programmed. So every cell is actually a representation of the entire body. So when you get a positive environment, then the curiosity, the empathy, the compassion, all the positive qualities also are also there. And I think one thing which I can see that, you don't need to kill the curiosity of the child. Many a times when a parent doesn't know the answer, we say, अरे क्या क्वेश्चन बाद में बताएंगे, और we just ignore the question because we ourselves don't know the answer. But with these books on quantum, I think both can be a part of the learning process. But sometimes for
I don't tell them the answer. Check in the Google. If you don't get the answer, come back to me.
no, because these are preschoolers, and they have to have the multi-sensory approach. Yeah. Because Google might give that kind of video which the government official was saying.
Vinu, there is a request. There are quantum parents out there. They have come 8:30 in the morning. They're leaving. You can just give a thank note to them. They came with their kids, ma'am. All 11th and 12th grade.
Okay.
But ask them to wait for 5-10 minutes.
I think they have to go, I suppose.
Oh, they are ready.
Okay. Done.
So now next I invite Ritika to talk about the parental awareness for students from the age group of 9 to 14.
So, good evening, everybody. First of all, I'd like to thank you all for being here. You could have been anywhere else on a Sunday evening, and I so appreciate that you chose to be here. And a big round of applause to Professor Pant for actually getting us all in this room. The reason why I'm asking you to clap is also because of state change. We talked about state change in the morning, right? It's important to get our state change, the electrons moving from one energy level to the other. So I'm going to show you quantum mechanics happening in life, in real life right now, real time. So just by a show of hands, how many people here feel that they have a quantum mindset? Now that you've heard about quantum since morning, how many, by a show of hands, have a quantum mindset? Sir, आपको उठाना ही पड़ेगा. Okay, great. By a show of hands, can I know how many of you would like to have a quantum mindset? I hope that's the entire room, right? That's what we are here for. So I didn't really break down parenting into this segment of 9 to 16 or 6 to 12. The quantum mindset is really relevant to all of us sitting here, even the students that are sitting here. But I'm going to relate it to the parenting bit, but also this, I can tell you that by the end of this presentation, you will feel that you are equipped to have a quantum mindset. You may not be fully aware of what quantum technologies are, what the future holds, but how do you approach it and how do you think in the perspective of the minutest is what you will learn. In my introduction, how do I move this? So in my introduction, the little student, she said that I'm a storyteller and I'm a children's author. So I try to bring in stories everywhere because that's exactly the way I learn, and I hope it's useful for all of you. So we are going to talk about the elephant in the room, okay? Has anybody here heard of the story, The 5 Blind Men and the Elephant? Okay, I'll repeat it for the benefit of those who haven't. So in this town, there were 5 blind men who had come, and they, obviously because they were blind from birth, they had never really experienced what an elephant is. So everyone went up and touched a particular body part of the elephant. So the blind person that touched the trunk said, oh, I didn't know, the elephant actually is like a, what? Like a snake, exactly. The person who was touching the side of the elephant said, oh, now I know the elephant is like a wall. The one who touched the ear of the elephant said, oh, the elephant is like a fan. Somebody else touched the tail of the elephant and said, oh, I didn't know the elephant is like a rope. And then somebody, the 5th person, touched the leg of the elephant and said, oh, I didn't know the elephant is like a pillar, right? So here, can we see a little bit of the observer effect coming in? What we are observing is what we understand, right? And sometimes what we observe will change its state, as what we have learned, right? That you start observing and it changes its state. For example, this happens with my son a lot. He's a footballer, he's a soccer player, and every time he masters a particular move, he'll do it 2-3 times and he's like, Mama, dekho, dekho. And jaise hi dekho, dekho, wo hota hi nahi hai move. So I think that is observer effect in action, right? Because that he says, whenever I ask you to see, then I'm not able to do it. So at a quantum level, that's what's happening. So today I'm going to draw some parallels between quantum mechanics and parenting for middle schoolers. This is actually applicable to parenting overall as well. We talked about electronics and semiconductors. We talked about this since morning, right? But the way I interpret this in a relationship point of view, or especially in the parenting realm, is the art of adaptability, right? So tiny particles like electrons, they are moving from one energy state to the other, they're changing their state, and they're adapting based on the electrical signals that they're receiving. Now, in the parenting realm, how we can look at this is, can we adapt to the changing needs of our children, especially as they move from, let's say, the preschool age to the middle school age, where maybe their friends are changing, maybe the teachers are changing, the curriculum is changing, everything is changing. But we expect the children to adapt seamlessly, right? We feel that it should come naturally to them, but they may need a lot of hand-holding, they may need a lot of understanding of what might be going in their internal thought process and in between their ears, the thoughts and the little voice between their ears. So we have to help them and guide them through these circuits of life. So, make sense? The electronics and semiconductors teach us the art of adaptability. The second is the multifaceted problem-solving aspect that we learned of quantum computing, right? So in parenting, I think the problem, every relationship can tend to be a problem factory, right? Every new age will bring you a new kind of issue to work with. And sometimes the solutions are not very straightforward. You might have to look at different options, right, in terms of making the right bond with the child, having the right kind of communication environment, the right ecosystem at home, which makes them feel that they have a safe space to come to. So embracing that, embracing the multiple perspectives as solutions, and understanding that our children also are living in a very different world. We've been talking about children who are born post-Facebook, post-Google. I think in another 3 years, we'll talk post-quantum computers, right? Children who are born post-quantum computers. So their reality is going to be vastly different from ours. The important skill as parents, because all the parents are sitting there, I say the important skill that we need to really embrace is the fact that solution एक तरह से नहीं आएगा, हमें different aspects सोचने पड़ेंगे, and we have to collaborate with different experts in the fields, right? Because सब कुछ हमको नहीं पता है. We have to work with different people. We have to make ourselves aware that parenting is not to be done on autopilot, okay? It is not to be done, it has a generational impact. How our grandparents parented our parents made a difference to how they parented us, made a difference to how we are parenting our children, right? So you see that there is a whole generational link there. MRI. I had the, I should say, bad fortune of getting an MRI done last year. I am very scared of the MRI machine. And last year I had to get into it, and I literally prayed for those 10 minutes, but somehow those 10 minutes seemed to pass quite quickly. But really looking beneath the surface is what this MRI technology in terms of parenting can teach us, right? A lot of times we feel that our child is not talking to us properly, or they are being disrespectful, or they are not really behaving in the way that we have nurtured them to behave. But we really have to dig down deeper to understand what might be going beneath, what are those quantum thoughts in their mind, which maybe they are also not aware of, that we need to really be patient and hold the space for them, right? How many of you here feel that you feel more comfortable talking to somebody who doesn't judge you or doesn't give you an answer immediately, right? They hold the space for you. So they allow you to talk, they allow you to express yourself, and sometimes you don't even need them to give you a solution. After just telling them, you feel lighter and you feel you've got your own solutions, right? So that's where we need to be. Understanding what's truly happening inside, and as parents, we have to look beyond the surface behaviors. Especially post-COVID, I'm getting a lot of parents who are coming to me and talking about the fact that their child has been diagnosed with ADHD, a lot of attention issues, a lot of impulsivity issues as well. So why are those behaviors manifesting is something that you need to understand, rather than simply saying that this is how the child is. Energy and lighting, these are all quantum examples, right? These are what I'm talking about, whether it is MRI or solar systems or whatever, solar panels, all of these are quantum phenomena, but I'm linking them to your parenting journey. So like light, it eliminates and it illuminates and eliminates darkness. Our guidance and wisdom can light their path and helping them see the way through complexities. And again, here, all of the things that we've been talking since morning, if we are in the dark, then how are we going to light up the room for our children, right? And you don't need to know everything, right? And you don't need to benefit the whole world. So there is a very interesting saying which I like, I don't have to be the sun to light up the world. I can just be a lamp and light up my street. And that is enough. If I learn enough to really give the right kind of impetus to my child to go and explore fearlessly, I think I've done my job well. I don't need to really leave a legacy per se. Chemical bonds, the strengths of connection, right? All of these again are quantum phenomena. At the quantum level, atoms bond with each other and they change this connection so that the bond is stronger and it is more stable. So the bonding process, I can draw parallels to parenting, is strong emotional bonds provide stability and security, right? And our speaker here just talked about these basic needs of a child, especially since she was talking about the preschooler age. Safety, security, being seen, physiological needs being met. You can't even talk about attainment of your life's purpose unless these are met. So we have to form strong connections, and middle school is a wonderful age. You should not miss that train, because this is the time when the child needs that kind of support and they need to feel that yes, their family is going to be with them. It doesn't matter that whether they take this career or that career or this or that, whatever. You are holding the fort for them and that's what they need to know. GPS, navigating with purpose. आज तक किसी ने भी GPS use किया है कहीं बिना उसका destination डाले? Anyone in this room? You've reached somewhere without putting a destination, sir? I need to learn that from you. Yeah, so that is one way, but you still know where to look, right? So unless you know where you're going, how can you direct your attention and your action in that direction, right? So God, it is, of course, we understand that through the atomic clocks, the quantum mechanics guides the GPS. But power of having a clear direction, and like one of our speakers also mentioned, and like ma'am mentioned, that there is no idea. If parents feel that general suggestion de do, work hard, but work hard in which direction? Work hard in being silly, or work hard in being lazy, or work hard towards what? So we don't have the luxury nowadays, in this day and age, we don't have the luxury to say, I don't know about this, right? You can always learn. What you should be saying, I don't know, is, I don't know about my child. And if anybody here feels that you know your child, I think that is one myth that we need to overcome, because we don't know what they are thinking, right? We have to be in that space of I don't know, because only in that space we will be like an empty vessel to understand exactly what they are feeling. If we are already thinking कि मेरा बच्चा ऐसा है, ऐसा है, ऐसा है, that means we have no space to really understand what they're going through. Instincts and innovation. So since morning we've heard a little bit about the migratory patterns of birds, right? And Professor Pant actually informed me about this, that I read about it, that they have a certain protein in their eye. The migratory birds have a certain protein in their eye, which is very sensitive to the magnetic fields, a change in magnetic fields. So they are actually, this change of the direction for the bird, they are also not consciously aware. It is happening at the quantum level. So again, since these major feats are being achieved even without us knowing, we have to understand that these wonders are happening within our child. We talked about things like soul. We talked about things like consciousness. We can't pinpoint where our soul is. We can't pinpoint where our consciousness is. We can't even pinpoint where our mind is. We know where our brain is, but we don't know where our mind is, right? It's a sort of a combination of thoughts and our history and where we come from. So understanding that is crucial in the parenting role. So I'll end with a couple of more stories. Has anybody heard of the parable of the two wolves? Okay, it's an old Cherokee tale where a grandfather is telling a grandson that in life there are two wolves inside of us. One is a good wolf, and that wolf represents kindness and bravery and love. and the other wolf is a bad wolf. And that wolf represents things like fear and hatred and greed. So the grandchild stops for a second and asks, well, grandfather, which one wins? And the grandfather says, the one you feed. So to me, this tale is representative of the idea of superposition, right? We have the good in us, we have the bad in us. Whatever we feed at any point is what is going to thrive. Why I'm telling you this is because I think you may forget a lot of the technical stuff that you've heard, especially if you're not from the background of science or physics, but maybe these stories will stick with you. Maybe something you'll take back here that it will remind you to be a more conscious and aware parent. Even the concept of entanglement, right? Or things like the butterfly effect, if you've heard about it. So this story, the starfish thrower, is a story of a little girl. She was walking by the beach and she saw there was a huge storm that was coming. So the starfish were being pushed to the shore. So she picked up a starfish and then she threw it back into the ocean. And then she did it with the second one. So there was an old man who was watching her, and he said in disdain that, what are you doing? Why are you doing this? This is not going to make a difference to all the starfish, right? But the girl stopped and she said, you know what? It made a difference to that starfish. So small, minute steps that you take will make a big difference. That you may not see it now, but like we were talking about roots in the morning, right? Your roots determine your fruits. So unless you have put the right effort in growing those roots through small, microscopic, atomic habits, atomic efforts, you will not see the difference. So lastly, embracing uncertainty, preparing for non-linearity. I think I'm the poster girl for non-linearity, sir. Honestly, like I have an engineering background. I did my BTech. I went to the US, worked in information technology, then came back to India, worked in education, then started writing for children, then now I'm a parenting coach. So I don't see any linearity in my journey, but I think that's the beauty of it, right? And if we can expect that from our children, I'm actually quite blessed to have parents who never for once asked me, what are you doing with your life? They were always fully involved and almost in awe of what I was doing, even when I was doubting myself, and probably that's why I'm doing what I'm doing and I'm speaking to all of you. So thank you for your time. Very quickly, if any parents are here and you need any support or guidance, this is the link to my WhatsApp group. You can scan this QR code. It will take you directly to my free WhatsApp group. I put a lot of content. There's a lot of good discussion that happens. More than 350, 400 parents on this group. And if you're not a parent, please feel free to scan this and leave a review if you found value. Thank you. Thank you for your time.
Thank you, Ritika. And what I can gather from the entire presentation, again, there are two things: quantum parenting and the parental awareness about the quantum world. And I think depending on the age group, it starts with the quantum parenting and ends when the child grows up at a stage where he needs to decide about his career. Then as a parent, you have to be aware of the quantum world. And I was just reflecting on that. When the child is born, the child is actually born with trillions of nerve cells. And whatever kind of environment we give to the child, these nerve cells make associations. They get connected. So more connections, more associations. Scientifically speaking, they say more IQ or more cognitive development. If the child doesn't get a very stimulating environment, these nerve cells start drying up. And then they are never regenerated. So I think that is the reason it is very, very important that as parents, we have to give that kind of stimulating environment. And then I was thinking that for preschool and for middle school, how can you teach as a parent the quantum? I have not looked at the books, but twice I heard about migratory birds. So it is so simple. So So I'll just finish this example. So, many times we tell our kids कि अरे देखो सर्दियों में ना, winters में ना, ये वाली birds जो हैं वो यहाँ आ जाती हैं, and our conversation stops there. Our conversation has just the explanation. In fact, as a parent, if I'm not a zoology student or I don't know the reason, I will say कि हाँ वहाँ सर्दी होती है, यहाँ गर्मी होती है, the weather difference, and गर्मियों में यहाँ पर birds आ जाती हैं. But if I'm a aware parent, I can introduce a little bit, which you were just mentioning, कि eyes में protein होता है और electromagnetic field. I don't need to sit with the book. I don't need to tell the child that, okay, come, I will teach you quantum. You know, I'm just standing on my, in balcony and you know, I'm just talking. The learning is happening just through conversations, learning in corridors, what we say. Yeah.
Just very quickly, I think I missed the part of what resources as a parent you can use for improving your knowledge about quantum. I think some of the ones that I found were Quantum Magazine. There is a magazine by the name of Quantum Magazine. There is Quantum for Kids. Qubit by Qubit is another one. And there are some resources on QEDC, which is Quantum Economic Development Consortium. So you can go on the website and you can find all of these. But I'm sure you could have found this on Google as well. So no extra value addition there.
So now let's move to Vandana Gulia, and she's going to talk about quantum readiness for parents of age group 15 to 18. Vandana.
Hello everyone. So I've deleted most of the slides because everything by now has already been covered. So what I'm going to share with you is my personal journey through the learning, of, understanding the perspective of science and the journey of learning of a teenager, because as a parent I observed it. So it all began one day on a debate, an argument about, does God exist? My son asked me this. So I told him, for me, I have discovered my own version of God, but I think that's your journey to find out for yourself whether the God exists or not, or in what way do you perceive God. And then it slowly went on to become a discussion about religion, and he said that I believe that a lot of times religion is used to threaten people, into to subdue them, into submission. And I said yes, but a lot of times religion is used to deliver important lessons, because we can't expect everyone to have scientific mindset. For example, fasting, it's inculcated into religion because it's good for us. And now it's proved by various scientific theories that everybody should experience, practice such things once or twice in a year. So, slowly taking one step at a time and understanding better. And understanding that his horizon has expanded now. Now he's not a small fish which I can contain through my knowledge. So what I did was to guide him towards more books and more information and more knowledge, which will satisfy his curiosity about understanding what life is, what universe is, how we are seeing things the way we are, and how we can better perceive things. And it led to his understanding, deeper understanding of such unbelievable concepts. Once we were traveling from Delhi to Udaipur in a train, and throughout that journey, he gave me a dumbed down version of the book by Stephen Hawking, A Brief History of Time. And I learned about a lot of scientific things which I was not aware of earlier. And I actually was in awe, and I marveled at how a young person sees all that knowledge and information which has been curated for grown-ups. So this was very exciting experience for me. And as he grew, I understood more and more things coming from him. I expanded my knowledge, and I had to expand my horizons of learning new things to satisfy his curiosity, to provoke his curiosity, and at times give him the answers of the questions which he would just throw at me and just look at me for answers. So one day, it was middle of the night, almost 3 o'clock, his boards were going on, and he came to me to talk to me. He was really anxious, and he said, my physics exam is in 2 days. My maths exam, which happened today, went terribly, horribly wrong, and I think I made a lot of mistakes. Either I'm going to fail, or I'm going to top the class. But I'm not able to focus on my preparation of the next exam. It's impacting it so much. I'm not able to sleep. I'm not able to study. I don't know what to do. Say something so that I can stop thinking about it. And I looked at him. It was 3 o'clock in the middle of the night. I looked at him and I said, Schrodinger's cat. He nodded and he said, good discussion. And he went back to sleep. So what he and I exchanged was this very famous thought experiment. in which there is a paradox of quantum superimposition, wherein a hypothetical cat in a box is perceived to be both dead and alive at the same time, unless it is observed. So until the box is opened, the cat is both dead and alive. So what he understood from this one word was an entire lecture of motivation and telling him, don't worry, it's going to be all right, and all of those things. Teenagers don't want to hear that. They want encapsulated information, which is precise, which is well thought of, which is relatable, and that is what I did. There are some theories in quantum world which baffles even the top scientists today, Einstein and Feynman and such like minds, which actually even common people like us can understand them if put to us in the simple language. What I have understood is that science doesn't require a precise wording or a definition for us to explain something to a person who knows a little bit about it but wants to know a little bit more. So what I have practiced in my life while talking to my teenage son and several other children is that I give them the understanding of how I perceive science without kind of entangling them in the difficult and very complex definitions. And there was a time when he was leaving India, he was going for his further studies, and he asked me, he said, aren't you worried? I'm going so far away from you. You will not be able to be with me. You will not be able to see me. So I said, well, I am a mother. I am present at two places at the same time. I am here and I am there. Don't you worry. This is a good luck and a bad luck for both at the same time for you. You will not be able to get out of it even if you wanted to. So what I always inculcated in him was that everything is possible even when it's not possible. Why stop where logic ends? Why stop what science cannot explain? Because something that has not been explained right now doesn't mean it doesn't exist. And quantum theories, one after another, have proved that we need to understand more. The more we understand, the less we understand, actually. So I have gifted my son the gift of curiosity, innovation, intuition, analysis, reason, the freedom to debate and argue with me. When he understands something better than me and he wants to tell me that I know nothing about it, so that freedom is between us. What also I have given him is the gift of being unreasonable. Like I said, where science stops, where the definitions end, there is another realm to be discovered after that. So it's an amazing gift not to think that what we know, everything ends there. So there is this amazing revolution called citizen science revolution. And I'm particularly fond of it because I've spent some time around this. It has helped me a lot to understand those complex problems of science. And it kind of is designed in a way so that everyone can understand what actually future sciences present to us. So this is a very interesting game which is designed by a physicist so that every common person can go online and play this. And what they are doing is, it's a simulation game actually. It is designed so that players can contribute. It is designed by this physicist actually. His name is Jacob. Now what he has done is that he aims to create a quantum computer with the help of gamers all around the world. So when people are going on this quantum moves game and they're playing the games, secretly everything is being curated, and those inputs from gamers are actually helping these scientists to design a quantum computer, harnessing the intuition and the power of people right from where they are. And his project is called Science at Home. Now, if you go to his website, you will find a treasure of resources, opportunities. Now, I have actually encouraged my son to intern at one of his projects. Science at Home is a treasure of various things like games for even little children. These games are also from Science at Home. They cater to all age groups. Even grown-ups can go understand basic quantum science and actually participate in solving the complex riddles of quantum world without having the PhD in those sciences. You might not be a scientist. That doesn't matter. This person, this physicist, he is looking for people like us to solve those problems. Because what they believe is that once people have acquired the knowledge of science and they have acquired those degrees, they try and function with that bias that, okay, we know this much and this cannot be done. For example, when the theory of entanglement was presented to be proved, Einstein said, I don't want to touch it, it's spooky. Those were his exact words. So as a scientist, they have biases, but as common people, we don't. So this website actually presents the opportunity to the scientists all across the world to study the quantum theories from the perspective of a person who has not studied science. How amazing is that? Another treasure of resources which I found, and I particularly was very hooked on to this, I have watched several of this person's videos. His name is Dominic, another physicist, very talented, and he presents all scientific theories in such simple terms, even a commoner will understand, a person with no science background. And they are very interesting, I must say. And you can see his YouTube channel has 1.4 million subscribers. So he actually, this is a very, very interesting place to go. If you want to suggest this to your teenagers for binge watching, I enjoyed binge watching all their videos. I have removed a lot of slides, but I will share some of the resources for quantum readiness in terms of career for people who are in 9 to 12, because they are getting ready to go out in the world and try and look for opportunity for themselves. So I'll share it on the group. Let's not take everyone's time here. What I want to say is that children from 9th to 12th can explore opportunities of internship. There are many places, like even at Science at Home, if you go to that website, you will find internship opportunities in the quantum field. So children can, or teenagers can actually begin exploring that world, showing their interest, contributing to it, and building a career in that field by interning. Several internship opportunities right now are available online. And of course, many resources have already been shared with you. I will also share them on the platform after this session. You can access them all. Like I said, I actually shrinked everything to say what I wanted to say and which was sort of left out. There is this line which caught my attention: the more we know nothing. It stands true. In common people's language, it may be magic, but in scientists' world, it is a whole new world to be explored. So the amazing gift that we all can have and pass on to our children is to stay curious and to stay excited. Thank you so much.
Vandana, and that reminds me, many times when parents come for career counseling, they will say that, ma'am, हम दोनों तो doctors हैं, इसको liberal arts करना है या social studies करना है, हमें तो आता नहीं है. So, for science and humanities or maths and history, they have certain mindset, they were talking about quantum mindset. So, all these, I think, the resources which you have shared are brilliant resources for parents, because at least they will not say that none of us is quantum scientists, so we don't know what my child is talking about. So, you don't need to, and I always tell them, if you're an engineer, you don't need to know, what MBBS is all about. That's fine. At least have this particular knowledge that at least you're able to converse with your child. So thank you so much.
I want to say here, when your child comes to wake you up in the middle of the night, just listen. My last message from my son is, I can't wait to come to India and tell you about, and there is a 2-line description of a new scientific concept I have no idea about. But I'm looking forward to it, as I have always. Like I said, he talks to me and he actually makes an effort to dumb things down for me so that I, as a person from a non-science background, can understand. I appreciate his effort. As a parent, what I can do is give him my time and attention and listen to him. That may be encouraging enough.
Yes, and that's exactly what they say, when as somebody has said, children learn what they live. So, when the curiosity and the excitement is from both the sides, our every cell also generates some energy, So we all of us have some kind of aura around us. So when both of you are in the same platform of learning, then it's a beautiful process of parenting. Parenting is not about controlling the child. Parenting is growing together. Thank you so much. And that brings me to one more point, that, we talk about such specific individualized drugs. You know, when I read about some articles in WHO, they are saying that, you know, we can have the in-depth knowledge about the DNA, and then accordingly, you know, drug can be provided and the disease can be cured. What about parenting? Parenting also needs to be based on what your child needs. You know, that's very important. If you're able to connect with that, then there is, no boundaries to.
There is a cure for those kind of parents. I agree with you.
So I know
oftentimes they're very simple things. I don't want to reiterate. I mean, basic fundamental things. I mean, like I said, you know, the least you can do is when your child comes running to you with something exciting, you can sit down with them and say, okay, talk. I'm here. Fundamental. Comes running to you with something exciting, you can sit down with them and say, okay, talk. I'm here.
And taking an interest in this, and to all the panelists, including the very last one, for saying things which are stimulating and interesting. I, as you know, can go on for hours. Beat V.K. Krishna Menon on his recorded the speech at the UN. But I will make only 3 sentences. And to all the panelists, including the very last one, for saying things which are stimulating and interesting. I am a great believer that every child that I see has the potential to do something which no human being has done. Recorded the speech at the UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. Recorded the speech at the UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That is my UN. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, we have no idea what humans are. I am a great believer that every child that I see has the potential to do something which no human being has done. That should be our aim, not make only 3 sentences. And to all the panelists, including the very last one, I'm not talking theory. I'm not talking theory. I'm not talking I'm not talking I'm not Delhi election is on this that they made there are more than 120 years old people, the more than 100 years old. So already there is our kind of Delhi election is on this that they made there are more than 120 years old people, the more than 100 years old. So already there is our kind Delhi election is on this that they made there are more than 120 years old people, the more than 100 years old. So already there is our kind of Delhi election is on this that they made
And for Professor mmpant. And I'm sure people, I think after today, we have a lot of people, half of the people, and a lot of people who are not doing quantum. And for Professor I love Professor Pant's idea. He told me and I'm sure people, because I think after today, we have a lot of people, half of the people, and a lot of people who are not doing quantum. A big hand for all the I love Professor Principal and the person sitting behind. I'm sure I was impressed in the morning, the parents were also here. So a big hand for everyone and pleasure to so many people I saw first time. A big hand for all the I love Professor Principal